Good morning, afternoon, good day, everyone. Thank you for being here. I'm excited about this. I hope you are too. We'll get started in just a few minutes at 7:30 a.m. California time. Oh goodness, and the chat is already moving. Hello, everyone. And yeah, if you're dealing with resolution issues on your VM, sorry about that. I didn't realize I had it saved for presenting on a projector, and that's why the resolution is kind of crazy. So you can go through settings, display, or people have put into the chat some other solutions along with that. Good morning, good morning, good morning. Thanks for being here. Good afternoon from Spain. Oh yeah, I've gotten the question a lot, will this be recorded? I believe so. From what I can tell, YouTube allows me to archive and post the video, and so that's my intention, unless something goes totally wrong, which it may, and we'll all roll with it, but yes, I intend to record. The question is, do we need to have the VM installed to do the webinar? If you want to do any of the exercises, then you need the VM. If you're here just to listen in and do the exercises later, then I guess you don't. Hi from India, Italy, Morocco. Wow, Israel. This is so cool. We're all or most of us are quarantined, London, UK, yet together we can all come together. Egypt, France. This is one of the cool things that I guess can come out of us all being locked down is New York, Norway. We're all here in a live stream together. This is so cool. Nigeria, Saudi Arabia, Germany. There's so many, I can't keep reading them all. That's a good problem to have. There's the question, can we get source code from the APK? That's, I think, the point of this workshop. We're going to talk about it because when you're reverse engineering, it's usually because you don't have source code. So I'll show you what we can get that's close. Increase the sound of my mic. Let's see. Hello, hello. Is that better for those of you asking for a louder sound? Please comment in the chat. There is about a 5 to 10 second delay from when I'm actually speaking to until when y'all can see it. So just know that if I'm talking or your questions or chats or things like that. Okay, cool. So I'm sure we'll have a few people trickling in over the next time, as well as maybe some of y'all leaving. I hope not, but sure. That's one of the great things about live stream. And so let's get started. Hi, my name is Maddie Stone, and we're here to do 4 hours-ish about Android app reverse engineering. First thing is, yes, in this live stream, I do have DVR enabled. So if you need more time on something, need to get up, go to the bathroom, have kids running around, just need to take a break, you can pause this live stream, go back to something I said, things like that. And then, as I said a few minutes ago, my intention is to have this video posted of this whole recording. Technology, I think it should work. If it doesn't, I'm sorry, but please know I'm trying to do it. And then another thing is that I have never live streamed before. I've taught this workshop a couple different times in person, but obviously this is going to be a very different dynamic just between even the technology and trying to make live stream working when I hadn't planned this when we all became quarantined 6 weeks ago. So I am running the encoding software and stuff off of a little laptop rather than, a beefier machine. So please stick with me. And I also want you to know that, I'm doing my best, the best I can. If something doesn't work, please go along with it. If you have a solution, offer it in the chat. But yeah, we're all in this together. So let's jump in. First things first, if y'all don't know me, why am I teaching this? My name is Maddie Stone. Twitter is Maddie Stone because great OPSEC, and my pronouns are she and her. I am currently a security researcher on Google's Project Zero team, but before that, I worked on the Android security team at Google for a while, where my whole goal was hunt malware and ruin malware developers' day and protect the 2.5 billion users of Android devices. So a lot of this workshop comes from that perspective of what I needed to learn to effectively reverse engineer Android apps when I joined the Android security team. But beyond that, I've been a full-time reverse engineer. I guess I should have updated this since when I first created the slides because, that time keeps ticking up. But more than 7 years, I think it's like 8-ish now. Started out hardware and firmware reverse engineer. And so that is why this whole course is going to be fully static reverse engineering. We're not going to get into having a device, how you run it, how you debug an app and analyze it like that. We're just going to look at the static reverse engineering. And the driver behind that is that I do think static reverse engineering tends to be a scarier, less approachable technique to people, just because if you're coming from a development background, you're used to debugging and running things dynamically. But it might seem scary to just have to figure out what something's doing by looking at its code, unless I want to make it approachable, because you can do it. And so when I had joined Google in October 2017 with a lot of reverse engineering experience, but no Android experience, this is all of the different things I had to learn to take that background in reverse engineering, background in analysis, and now apply it to the Android platform. So yeah, that's kind of from my experience, that background. Let me try and catch up on some of the chat to see if there's anything. So still a little louder. Let's see. It seems like it's a little different. So it's now saying that it's going to get a little fuzzy if I go any louder. So we'll try right here. If you're still seriously having problems, comment in the chat, but it seems like a lot of people are not having issues, so we'll see. Lastly, I really love this stuff. I hope you enjoy it, whether it's your first time or not. But either way, it can be an everyday type of thing or a tried it in Maddie's workshop, not for me, but cool. I'll leave it to those people. So let's have fun. Second, we do have 4 moderators that will be coming in and out throughout the 4 days. So huge thank you to them because, as you can see, this chat is moving quite a bit. And so it would be very difficult for me to do back and forth. So we have Tim Willis, Brandon, Alec, Natalie, Tim is our manager over in Project Zero. Brandon and Natalie are both my fellow researchers on Project Zero, and Alec has was one of my fellow team members on the Android security team. So they are monitoring this chat, trying to help you out. And a huge thank you. Please make sure to thank them too, because they're giving up their time as well to help keep this a fun, productive community. So what's the point of this? My goal whenever I teach a workshop is not to teach you how to complete the set exercises I've put out there. My goal is to give you the necessary foundations so that you can then have the tools and the understanding to take that and apply it in however you want to from here. Because there's a lot of different reasons why you might want to do Android app reverse engineering. So you may want to do malware analysis. You may want to do vulnerability hunting. You may be an Android app developer and want to understand what attackers may be doing to your apps to better secure them, better write them, things like that. You might be doing content reviews. So there's a lot of different reasons why we might be using these technology. And so my goal is not to teach you how to do one single thing. It's to provide you with the knowledge and hopefully then the confidence to take these foundations and then run with it in whatever way you think is best for you. And, obviously, let's have a whole bunch of fun. So non-objectives that I need to just put out front. One, you are free to leave at any point. You don't have to say if this is not serving you. So first of all, this won't be a general intro to reverse engineering. We're not teaching you how to do an Android app, not teaching Java, all these different things. That is not my goal. That doesn't mean that you have to already know all of these things. Just come into this with that growth mindset of, I might have all these competencies and this is hard or it's easy, or I might not know any of this, but I want to give it a shot and see if it's something I want to learn for in order to be able to do. So if things are hard, if you don't have the prereq, that's okay. Just take what you can from it. Use each other in the chat. If we were in person, I would really be emphasizing y'all to work with your, the person sitting next to each other, build that community of asking questions, using each other's backgrounds. Clearly, we are all spread out all over the world. So do what we can, and I hope you keep a positive outlook, because if it ends up being something you want to learn, you can go and learn all these things. And hopefully I'll show you what fun things you can do with it. The last thing I want to emphasize, I've already talked about this a couple of times the chat's over here, so when I'm looking that way, that's what I'm looking at. So I think it's pretty exciting that all over the world, we are now in this together. And I do think the InfoSec community can be the super exciting, productive, supportive way for us to help people. As I said, there's over 2 billion users of Android devices, and we, with these skills, can help them, can keep them safe, can ensure that they have safe and secure access to the internet. And so I want our community here for the next couple of hours to be supportive of that message of, we have moderators because we're not going to have tolerance for talking down to someone else, talking down or being crappy to me, your fellow workshoppers, any of the moderators. Use this as an exciting time to support each other. If you're already a part of the InfoSec or Android security community, I'm glad you're here again. We're glad you're in the community. We want you here. If you are giving us a chance to consider being a part of the community, thank you for giving us this chance, and hopefully you decide it's something you want to join, because we can use all the hands we can get, and we would love to have you. And so lastly, I am doing this all for free, but we are in a pandemic. A lot of people are really, really hurting. I'm sure some of y'all are as well, and so I'm trying to send love and hopefully a little bit of brightness to you in your quarantine. But also there are people in our communities who are truly struggling to even eat and basic needs. So if you have the means, and if you would have been willing to pay a couple of dollars to see me do this, please consider donating that to the San Francisco Marin Food Bank, who is really struggling to keep up with the supply here in the California Bay Area, or your local food bank. Thank you, thank you, thank you so much to everyone who's already donated. We've raised over $1,000, which equates to over 2,000 meals thus far for the Bay Area, but there's even more needed. So if you're even willing to donate $1, that means 2 meals for someone. So thank you. Now let's get into it and have some fun. We're scrolling. Let's see. Cool. So just checking to make sure, chat-wise, we're good. Okay, sweet. Sorry, as I said, live streaming, so learning how to do all of this at the same time. Oops. So first, let's talk about tooling, because if you're going to get into this and do this more, it's always good to know what tools do you have on your at your disposal. So we're going to use a couple of different things, and we'll talk about what their role is. And ooh, I'm in a weird sunlight. And we'll talk about the different roles they play in our reverse engineering. So first things first, we need a Java decompiler. It takes Android apps are usually written in Java or Kotlin, and so these tools are what lift the bytecode back up to Java-ish code so we can read it and understand it. So the one we'll be using today is called JDEX. It's free, open source. There are some feature requests that people always have after they take this workshop, but one of the cool things about being open source is that you can help build that for the community. The next one is called Jeb Decompiler. It is not free. I think it's about a little over $1,000 US. So personally, I only really use it when an employer is willing to buy it for me. It has some features like cross references or callers that other tooling such as JDEX doesn't have, which can be super crucial. But then JDEX has some other features that Jeb doesn't have. So if this is something you're going to get into doing day by day and make money from, that might be a good tool for you to consider using. Another one is Bytecode Viewer. So it sets up a different UI than JDEX, but then uses decompilers like JDEX and others under the hood. One of the nice things about Bytecode Viewer is that because sometimes a decompiler can fail, since it's a, oops, I'm in the sun. Well, oh well, I'm kind of squinting. Since it's a, since they're all written by humans, sometimes they can have bugs. And so one of the nice things about Bytecode Viewer is since it uses a couple of different Java decompilers, it can end up, you can look through a couple of them in case there's an error on one of them. So yeah, those are our options for Java decompilers. Bytecode Viewer is also open source and free. Disassemblers, why IDA Pro is the industry standard, not free, costs about I think $1,300 for a single person's disassembly license, not including decompilers, but it is the industry standard. However, last year Ghidra came out from the NSA, and it is free and open source. So if you are just getting started, that's a great tool because it has both disassemblers and decompilers, and it's having a lot of different resources be built around it, documentation and stuff like that. Another one is Binary Ninja. I actually haven't used that extensively because I've always had a company who was buying me an IDA Pro license since I was doing this as a day-to-day job. But there's a lot of support, and they just released a new higher language, intermediate language, which is quite a bit like a decompiler. So I think that's another great option out there. Today, since we are breaking this workshop up into pieces and only doing the first part, we will not get into disassemblers, but I feel like it's good to still let you know the tools, and if we jump into part 2 at a later date, that is what it's doing. So some other important tools for any Android analysis is one is Freedom. if you move past just doing the static analysis that we're talking about today and then getting into dynamic analysis as well, Frida is a really awesome hooking engine. Oh, these slides were written before I started using it. I've used it a lot more now. Did a conference talk about using it back in October on WhatsApp, and it's a super awesome tool. Highly recommend if you're really trying to instrument and understand an app. APK tool is another great resource. I don't need it as much when using JDEX already, but it's another free thing out there for you. So let's get into some Android app. Oh, there's some questions about R2 Hopper. There's a lot of people who like it, who use it. I have never really had a need between IDA Pro and Ghidra, but if you don't already sort of have those tool chains and things you're working through and processes, then yeah, definitely consider it. I think there's a lot of reason why people love them, and they're both free as well. But yeah, I can't really speak to them because I haven't been using them. So, quick and dirty, what is an Android app? If you need to know more about this, maybe pause and read up. There's resources in the GitHub version of this workshop. So we have an APK. That is the file extension for an Android app. You can open up and extract the contents of an APK by, the sun is weird, man, by just running unzip on the APK, and then you can extract all of the contents from that file. And so things that you'll usually find in an Android app or an APK is, first, you will have an Android manifest. It is an XML file that tells you things such as what are the permissions, what are all the different components of the application, such as services, activities, things like that. So it lists all those different facts about the application within it. The Android manifest, although it has an XML file extension, it is usually compiled XML, and so what that means is you usually have to decompile it. If you put the app into a tool like JDEX, it will automatically decompile it for you, so it is human readable XML. Otherwise, you might need to use a tool like APK tool to decompile it to bring it back to human readable XML. You'll then have a directory called meta-inf. So any certificates for the app will live there, telling you who signed the application. Then we have classes.dex. This is our Dalvik bytecode for the application. So Android apps can be written in either Java or Kotlin. I see there was a question of what is Kotlin. It's just another language that Android apps can be written in. I think it was added 1 or 2 years ago as an opportunity. I will largely just be saying Java because they're both brought back to Dalvik bytecode, which is what the Java or Kotlin codes run in the VM on Android. So yeah, if I say Java, I largely mean you can write in Java or Kotlin, but it basically comes down to the same thing. Then you'll have a directory called lib, which along with the Java or Kotlin, developers can also write native code for their application, such as C or C++, and compile it down. So the default location where any of those libraries would live is in the lib directory. They don't have to, but that's the default location. And then within the assets directory is any other files the application may need. So such as, does it use images? Does it have sound files, font files? Or the developer could choose to put any of their native libraries or extra dex files there in the assets folder. So the reason why you may have extra dex files is the benign reason may be that you have more code than can fit in a single dex standing for Dalvik executable, or sometimes malware developers will try to hide extra dex files that they will then dynamically upload, and so they may label them without the dex extension and put it in assets, like try and hide it as image 1, 2, 3, 4 under assets, but then they use the code in classes.dex to dynamically load it into the application. So I've used the term Dalvik. What does that mean? So when you are a developer, we're going to start at the right side because that's what a forward engineer rather than a reverse engineer would do, is they're going to write their Java and then build it. And that's going to end up, this sun is intense, y'all. Usually it's very foggy in San Francisco in the mornings. But here we are. So usually a developer would write Java and then they would build their application. Within that application, it would run Dalvik bytecode, where the name originally comes from. In early versions of Android, it was called Dalvik VM, or the Dalvik virtual machine. Now Android has the Android runtime, but we still use the term of Dalvik bytecode. The way you can think about this is if you have done more native reverse engineering before, is that you would write C or C++ and then it gets compiled down to machine code. So if that's the case, and then we as reverse engineers, we don't get the Java code that the developer wrote, just like as reverse engineers, we wouldn't have the C or the C++ code that other native application reverse engineer or developers would write. We instead get the Dalvik bytecode from within the application. And so then we want to begin raising it up so we can get a more human readable version of it. So just like with C or C++ applications, if you had the binary, you could then use a disassembler to get to the assembly language and reverse engineer that. And maybe if you're using Ghidra or have IDAPRO's decompilers, you could then use the decompiler to get to decompiled C pseudocodish stuff. We can do the same thing with Java and Android apps. So Dalvik bytecode can be raised one level to what is called Smalley. It is very similar to what you would think of as assembly for machine codes. It has basically an instruction and then it takes arguments or opcodes. You can read more about it in the listing of this GitHub workshop. We're not really going to deal with that today. I just want you to know that it exists. But instead, we can also take it up another level using a decompiler such as JDEX or JEB to get to decompiled Java. So it looks very similar to the source code that the Java developer may have written. So one thing to know about Smalley is the only times I really go back to looking at the Smalley code is when I think there might be a bug in my decompiler. Smalley is one level closer to the ground truth of what we're trying to reverse engineer. So it's a good thing to look at if you think what the decompiler is showing you might be incorrect. So this is just an example of what Java versus Smalley looks like, just for your awareness of, let's say we have a print hello world method here, then this is what the Smalley would look like below. And so I linked to basically the equivalent instruction set architecture using assembly language or terms if we want to apply those to Smalley in the GitHub link. Let me see. Cool. So some of the first things we want to do when we are reverse engineering an Android app is we need to understand what are entry points to an Android app. How can code begin executing? Where is the start or the main function that as soon as you call it to start running, what is that code that's actually executed? So there's actually a lot of different entry points that can begin for an Android app. So the first one is called a launch activity. If you do not know any of these terms about components for an Android app, then I would suggest at some point going back and looking them up. The overarching thing is an activity is code that is running with a specific UI. So that is what an activity is. A service is something that's running in the background without a UI. It can be running at the same time as other activities. A receiver is something that is waiting to execute based on a message it receives. So let's say it's saying, I'm waiting to run until a call comes in. I've registered that I just want to receive the signal when a call, and that's when I begin executing. An info provider is basically a database that provides different information, such as here are all contacts I'm providing, or here are Facebook friends that are being provided, or things like that. So that is an info provider. There's also something called the application subclass. So Java is an object-oriented language. Every Android app is from the application class, and they can also declare an application subclass. And so, okay, I skipped ahead. Let's talk about how these can be entry points and start running. The first one is, and this is all written in depth in my GitHub workshop, so feel free to also, it's all written out there if you prefer that to me speaking on a slide. So first, a launch activity is in the Android manifest. It will be declared as the activity that starts when you have your phone, you have all the app icons, you press on one. The launch activity is the thing that is started whenever you do that. A service is something that it can be provided in the Android XML and say, hey, other applications can start me by sending this message or by calling this command, and they can start this background service. So that a service might be something like in Gmail that's, you're not using a UI, but it's running in the background to check if you have any new emails to then tell you about or start the application. A receiver is something, like I said, where it's waiting for a call. So your dialer application, which you know is the normal phone on your Android app, and so it might say, hey, we're going to start this application, not when the user, just when the user presses the button, but we're also going to start and show the UI whenever I notice a call is coming in. And that's how it then displays, you know, so-and-so is calling you, and you can start talking to them. So the application subclass, if an application has this defined, which I'll show you we can find out in the application manifest, then this will always start and run before any of your activities, services, or receivers. So it always runs before those. The one thing it will not run before is if an info provider has been declared. Because an info provider is a database providing necessary information, if that has been defined in the Android manifest, that will run first. The application subclass, again, runs before any other activities, services, or receivers, though. This is important to keep in mind because what I've also actually found is that malware developers in the Android ecosystem will use this to try and hide their behavior. The launch activity will look totally benign, all the services, receivers will look totally benign, but then they will have declared an application subclass. Because that runs before, they will then actually pivot and use that application subclass to start a whole different set of code to execute, and they will never actually call their launch activity because that application subclass doesn't return. And so they then have all this other malware, malicious code that's running rather than what looks like the benign normal code. There's questions about, oh, yeah, my moderators have been all on it. Thanks, moderators. Please remember to thank them too. Cool. The last thing to keep in mind, and this sort of goes on top of all the other options of activity services and receivers, is that a developer can say, we are exporting a component being activity, service, receivers, info providers. And so if they say exported equals true in the Android manifest, then that means that any other thing running on the device can go ahead and start your service, receiver, activity, etc. And so this is something to keep in mind. This is something to keep in mind because that is then a way that, you know, a maybe unprivileged component, a random untrusted app on your device can start privileged execution or send commands or things like that. So those are our application entry points. But if we now understand some of the foundations of what the application entry points are, where do we start with RE? one of the biggest things I find with people new to reverse engineering is that you just want to start anywhere with code that might make any little bit of sense and then try to understand every single line that is within an application or a binary. I've been there too. It's part of what makes us great reverse engineers is we want to understand everything. However, in most of our jobs, if we're doing this for a job rather than just for fun, time constraints and priorities usually mean there is not the resources to allow us to reverse engineer every single line. So we need to be deliberate about where do we start reverse engineering, not just anywhere we see code, but being very specific of what we're trying to do. So the first thing to always ask yourself is, what is our goal? And that goal may be a few different things. It may be, I need to make the binary decision, is this malware, is this not? I want to make the decision of, does this have a vulnerability that would allow access to this privileged component? My goal may be, I need to figure out if it is showing malicious ads or content not fit for a child, or something like that. So keep in mind what is the actual goal you're trying to solve, and the more specific you can be, the better it is. So even if your goal may be very broad, such as, is this malware or not? You can then break that down of, okay, I need to decide what type of malware. Is this SMS fraud? Is this doing spyware? To then help you decide, where do I want to start reverse engineering? What is my actual question I need to solve based on the information that has been presented to me thus far? And so then you use your app entry points, because most of the time, many of us are not very interested in any code that is not able to be reached or executable. And there is a lot of cases where there may be dead code still within an application. And so keeping in mind your different types of entry points so that you can ensure that the code you're reverse engineering has a way to actually be executed. The next thing to keep in mind is that basically everything interesting you're looking for has to be done by an Android API call. So let's go back to our SMS fraud example, which we'll be using in some of the exercises. It is a type of malware that the Android Security Google Play Protect thing considers malware, and so they will flag it if they find it on an app on your device. And what it means is that an application is sending a premium SMS message without the user's consent or knowledge. And so a premium SMS message, that's not super common in the US or Western Europe, but it is in other parts of the world, is you send it to usually a short code, so not a full phone number, but like 55355 or something like that. It's registered with a very specific carrier, and then anytime a user texts that number, it takes so much money off their bill, like $5, or something like that. In the US or Western Europe, that type of premium SMS message is largely only used for like sort of disaster relief, like there was a hurricane, text this number to donate $10 to the Red Cross or something like that. So if we have that, then we need to break it down of what behaviors do we need to find in order to make that determination that yes, this is SMS fraud or no, it's not. Well, one of the critical aspects is the application has to be sending a text message. And then there's only so many different API calls that allow you to programmatically send a text message from an application. And so just Google it up of, how do I programmatically send a text message from an Android application? And you'll find that there's only a couple API calls. Wrong hand, that one's blocked. Send text message, send multi-part message, SMS to : and there's one more that I'm forgetting. So there's 4 different API calls you can be searching for. And if one of those 4 API calls doesn't actually exist, then it's less likely that they are able to do SMS fraud because there's not one of those API calls. Other ways you may be looking for, if you don't directly see one of those applications because that more sophisticated adversaries might not make it that obvious, is you might look for things like Dex class loader, which is doing dynamic code loading. So they're loading another Dex file or they're doing it in native code, but you get the idea of sort of like on, let's say, Linux, everything of interest can largely be brought back to like a C library call or a syscall. In this case, we're looking and interested in the Android API calls. Those are all well documented, so they're not something you have to memorize. Just think like a developer of, let's say I'm a malware developer who wants to write something that is programmatically sending text message, then use those same type of searches to figure out how to do it. Yeah. And the last thing is, if you're not seeing strings or stuff like that, Java is a language that relies very heavily on human readable strings to just be able to function. And so if you're not seeing any of those things or seeing really interesting API calls, then it likely means that your Android app is obfuscated or encrypted. And so that can be another great starting point if none of these other ones pan out. So we're here, we're ready for our first exercise, get into doing some hands-on work. So for each of the different exercises in this workshop, can you see me if I scooch this way? Let's see. Okay. Oh, yes, I'm out of the sun, and I think y'all can still see me. Okay. I should have done this sooner. Sorry, I kind of crack myself up sometimes, and it's really weird because y'all can't respond to me right in front of me. But yeah, so exercise conduct. I'm going to give this to you because, as I said at the beginning, my goal is not to just teach you to be able to go through a single exercise that I decided was good for this workshop. I want to give you the tools so that you can learn something specific and then apply it to other apps that have not been crafted for an exercise on your own. So really giving you that sort of self-sufficiency type of tools there. And so each exercise will have a context to really put you in the mindset of why in a real world would you be doing this work, and thus talk you through how to approach it so that it just sort of applies better outside of this workshop context. So the exercise context for this is, you are a malware analyst for Android applications. You are concerned that this sample may be doing premium SMS fraud, meaning that it sends an SMS to a premium phone number without disclosure and user consent. And so one of the other things to keep in mind is, if you're a malware analyst, that means you're usually trying to make decisions very quickly because you have a whole host of apps, and the longer that it is not either flagged as malware, that means it could be harming people. So that's sort of some of the other things to keep in mind, is that's why you might not have the time to look at every single line, and thus have to really make these determining factors and be very deliberate in each choice. So what is premium SMS fraud? It's a form of mobile billing fraud where an app sends a premium SMS message without the user knowledge and or consent. The SMS adds charges to the user's mobile bill, so they're stealing, which isn't cool. So there are three, other hand. This is hard. Okay, I have to do it in front of my face. So there are three things you have to do to send an SMS message. One, be premium SMS fraud. One, you gotta send an SMS message. Two, that SMS message needs to be sent to a premium number, which is usually a short code. So, it's not like in a photos app, you select that you want to send a photo to mom. That's not premium SMS message fraud, because there is no fraud going on, and it's also not charging any money to your mobile bill. And then three, that premium SMS has to be sent without user knowledge or consent. And so that consent has to include usually the disclosure to the user, and then them hitting OK needs to include the amount of money that is being sent to the user's bill, and then two, what phone number is it being sent to? And that's sort of like full disclosure and transparency, so the user can make smart decisions on their own. So the goal of this first exercise is we're not actually going to RE it yet because I want to really hound in that aspect of being deliberate with our choices, because that type of pattern and habit really serves us well going forward as we do more and more reverse engineering. So using the information and starting points for RE and app entry points, I want you to just start by determining a Java class or classes where you think you would start reverse engineering. So you open up the tool, you're ready to click on a Java class to say, I'm going to start going through this code. What class is that? Where do you want to look? And remember, the class you want to start with, you're hoping is going to help you determine or the answer to the question, is this application doing premium SMS fraud? So how do we start? Okay, so I actually can't run the VM while running this encoding software, I learned. So I have to run that natively on my Mac in order to be able to both stream at a high enough resolution and do the work. So first, I want you to open up your VM, and I will give you a second to do that. And then the next thing we're going to do is we are all going to start up JDEX together, because I talked to you a lot of things about finding the manifest of the different tools we're going to use. So we're going to walk through that together and then go to answer this question. And this is a weird part because there's a delay. And so I did add JDEX and both JDEX and Ghidra to the path in the VM. So you will be able to just run it straight without going to a specific directory. And I'm going to make my terminal a little larger font. So we are going to start with JDEX-GUI is how you can start running JDEX. Oh, opened on my wrong monitor. Yeah, so when I'm looking this way, I'm looking at y'all's chat. When I'm looking this way, I'm looking at my monitor, which is the window that's being streamed. So the first sample we're going to open for exercise number 1 is tiecamera.apk. And so all of the apps that I use in this workshop are real apps. I didn't craft them for you. They are all real things that were already open source and public. And so you're doing real malware analysis and real vulnerability hunting. Oh, y'all asked for, oh, even a bigger font size? Okay, I thought I tested it, but I can do that. So if you need to change the font in JDEX, oh wait, I can't tell y'all that because I'm using Mac versus the other, but there's a preference or edit to be able to change size and things. Okay, so let's make that. Okay, so my JDEX font size is bigger. And then I'll make that bigger too. But all I did in the terminal, and you can do it in your VMs, is run JDEX-GUI. If you were to just run JDEX and then a file name, it will output. I'm trying to, okay, I can't determine based on the chat and the delay if the new larger fonts are big enough or not. I'll make it slightly bigger just in case. Okay. I don't think I can make it any bigger than that. So hopefully that works. So again, you're running JADEX-GUI to open up this JADEX. And what I was saying is JADEX also has textual decompilation. So you could just run on the command line JADEX and the file name, and then it will do a text file output for you of the sorry, I'm getting some alerts from encoding overloaded. Hold on. Okay, so give me 1 second as I tested this. Okay, I think I might need to leave it like that. So, backing up, you can use JADEX and just the file name on the command line in order to go ahead and just do a decompilation output like that. And that will just do like a text file of the decompilation if for some reason you wanted to grep or search, something like that. Okay. And the app that we are using is tycamera.apk. No, none of the APKs are available hosted from me separately. They are all on VirusTotal because that's why, since they were already public, I chose to use them, but they are malware. I'm not going to host them. That would be irresponsible. So first things we got to do. Okay, sorry. This is, like I said, first time live streaming. There's a lot of inputs of information to me that I'm trying to consume. So first thing I want to show you is I talked a lot about the Android manifest and how that can tell us important stuff about the application we're looking at, such as the entry points. And so the way you can access the Android manifest file is go to, on the left-hand side under resources, open that up, and then you'll see Android manifest.xml. And so you can see here that it goes ahead and will decompile it for us, so this is human readable. And so the first things we can see up at the top is the permissions that this uses. So if we are looking for SMS message, well, in order to send an SMS message, it's going to need the Android SMS permission. So send SMS right here at least tells us we're on the right track because it will need that in order to send it. There's sometimes a lot of confusion, and I see on and I can already see. Oh shit. Okay, I see the video's lagging. Give me a second to try and reduce JADEX's memory consumption. It was fine this morning, I promise, I practiced. Okay. Okay, let's see. Let's see if it likes me better now. It's still gonna, YouTube is still telling me to give it a second. So YouTube hasn't caught up yet, so with the changes I've made, and neither has my encoder. So let's give it a chance to try and catch up to the changes I've made before we make any other changes. Okay, it, it looks like the YouTube stream is lagging about 2 minutes behind me, so we're going to let it catch up to where I'm at. And y'all can't hear this. Okay, so, oops. So again, let's open up the file. We're using tiecamera.apk. And so like I was saying, you can access the Android manifest, which is that XML file that tells us so much about everything that's going on by going to resources, expanding that, and then you'll see Android manifest.xml. The screen should be right now, if you're curious about JADEX GUI, is there should be tiecamera.apk in the output on the left-hand side with the actual XML contents on the right side. Is that what y'all are seeing? I'm not talking, so if that's what y'all... Okay. It seems that YouTube is much happier now. Yay! Okay. Once you hear this, can everyone send a smiley face in the chat? Okay. Okay, thanks y'all. So here we are. We have our Android manifest. Before I realized this was going so poorly. Okay. Wait, I think I can turn this down even more since it's saying... Thanks for all the smiley faces. I see them. Okay, one more time. Now we're gonna just move along. Okay, so here we go. Tie camera APK. Now we should know how we are doing this. So we opened it up. Here we go. Resources. Android manifest. So as I was saying, there is often a lot of questions on Twitter about there's a lot of questions on Twitter about why do people not say this is malware? Why is this allowed on the Play Store? Why is this company allowing this on their store just when something has permissions? One, for privacy aspects, as a developer, you should always use minimal permissions, and as a user, you should always highly vet the permissions an Android app is asking from you. However, asking for a permission, requesting a permission does not make something malware. They have to do the bad behavior with it to make it malware, at least as far as Google Play Protect is often concerned for that highest thing. So that's where just having send a SMS permission of this application that claims to be a camera does not automatically make it SMS fraud. We need to go back to what it feels like we talked about, 3 million years ago now, of the different the different sides of the three criteria that makes it SMS fraud. So sending an SMS message, that message is being sent to a premium phone number, and it is being sent without disclosure to the user or consent. So that is the permissions part of our manifest. We talked a lot about app entry points, and I told you those could be found within the manifest. So the first thing we talked about is the launcher activity. As a reminder, the launcher activity is the thing that is started whenever you as a user click on the icon on the phone. So the way that you determine the launcher activity is you look for this labels within the Android manifest. So intent filter on the activity, action equals main, category equals launcher. That means here, this activity, com.cp.camera.loading, is the launch activity for this application. So anything with this activity label means it's an activity within the application. Anything within the service label makes it a service, receiver, something like that. So and then provider is an info provider. So I mentioned application subclasses, and I told you that if an application declares an application subclass, then it will automatically tell you, or that will automatically be run before any other activity, services, or receivers within the application, even that launcher activity. So you determine if an application has an application subclass by this. If it has an application label with a class in here. So let's see. We have it. So here's the class name for our application subclass. Some other important aspects of, and then exported components. So let's see if we have any in here. An exported component will have a property value of Android:exported equals true. By default, if they don't declare that, and they don't declare any intent filters, Android exported equals false. However, as soon as you declare any intent filters on your component, that automatically makes your exported equals to true. So in this case, for this service, though they don't explicitly say Android exported equals true, because they've put these intent filters on here, it is now exported, and thus any other thing on the device can start this service on their own. So you want to make sure that then service doesn't do anything privileged or sensitive, because an untrusted application could then start and interact with it. So I think those are all of our main aspects of the manifest. Some other important things, the way that you see the decompiled source code is you open up one of these, or these little arrow thingy jiggers. Let's say we were trying to go to this service name, so it's com cp camera and then boot service, the class telling us it's a class rather than, you know, like an interface or something in Java. So it's going to be a little slow because I limited its memory access. I'll look over here. I think I'm back now. Let's give this a minute to fully come up to see if it's much happier with me. And com.cpcamera.boot service did open up, and so that's what we are in now. Once you are hearing this, can you please send something happy in the chat? Cool. Just so I can know. Oh my goodness, there's 1,200 of y'all here. Hi. That's intimidating. Thanks for being here. I know you're taking time out of your day, and so I don't take that lightly, and I'm honored. Okay, cool. I see you, and it looks like YouTube is much more happy. They're saying stream is healthy. Hopefully we can keep it like that. Sweet. Cool. So we are in boot service. This is what decompilation looks like. However, remember, this very first exercise, we are not reversing yet. We are making deliberate decisions of what we think is the best place to start. And so other people who've taken this workshop were very unhappy about my use of strings. The reality is, as a reverse engineer, if strings are provided to me, oh boy, do I use them. Why would I look a gift horse in a mouth like that? So the way that you can search for strings in JDEX is you can do text search and look for whatever you're looking for. Some of my suggestions to you is looking for API call, so the method names of API calls you may be interested in. Maybe just seeing if they happen to leave symbols in, you know, and thus called anything, you know, send message or do premium SMS fraud or any strings like that. You never know what might happen. So that is now what I'm going to give y'all a few minutes to do. Feel free to ask questions in the chat. I will chime in a few different times. And remember, just these are the three things that you're looking for in order to make that determination of, is this app doing premium SMS fraud? So don't start reverse engineering quite yet. Just decide, what do you think would be the best class or classes? There's more than one right answer where you think you would start your reverse engineering to find these things. Yeah. How do we search for strings again? Up at the top in JDEX, you're going to go to Tools. No, you're not going to go to Tools. That was incorrect. You're going to go to Navigation and then Text Search. Navigation, Text Search, and then you can search up here. I suggest switching this to class, method, field, or code. You know, you have all those different options to you. Default is case insensitive. If you're looking for a specific API call, then you can do case sensitive. The Android docs are good, so you know you can look for different things. So I'm going to give y'all, since I think there's a little bit of a lag, so I'm going to give you a few seconds, not seconds, a minute or two, and then feel free to throw out in the chat what you think is the class you would start with and why. I think the why is where we can really learn the most. And it helps you really think about what is your thought process when reverse engineering rather than just jumping straight into code. No, I'm not talking right now. I'm giving you exercise time in case that's a question. So one of the things I think about, is again looking up what are the APIs to send a text message. I see a couple different suggestions of loading class. Anyone want to share why they're choosing com.cp.camera.loading? Someone says common status codes. What's the full class name on common status codes? I see com.cp.camera.boot service. Boot service and loading have some mighty fishy looking HTTP requests. That's a great reason to look too. Boot service. Okay, so a lot of y'all have options. If you're still working, feel free to pause me, and you can come along. But so there's a couple of different ways to do this. And so if we go back to our Android manifest, then ComCP camera loading could be a great start, even just based on the entry activity if you don't have anything else. But especially with SMS fraud and when it doesn't look like the app is highly obfuscated, like in this case it doesn't because we did see strings and stuff going on. My usual go-to is to look for API calls. And so send text message tends to be the most commonly used SMS API versus say SMS 2: or send multi-part message or stuff with PDUs, which is another way to send them. So and look here, we have two different places where they call the send text message API. So let's just go to the first one. They're both, I think, even in the same method. So if we double click that, because I'm running JDEX on lower memory, it's a little bit slower, but that wasn't too bad. And so we see actually here, we have two different places where the send text message API is called. So yeah, that would be a great start to begin doing the reverse engineering. Someone else said, someone else said choosing loading because of SMS manager. Someone else saw the sent SMS action, which I believe is over here in our manage. thought it was over here. Maybe I'm just not scrolling it, but one ways you find if you don't know or let's say the API call search didn't bring up anything. Something else I also do is just look for SMS. So you might have seen sent huge SMS action, which that would be definitely a reasonable thing, sent SMS action. So these are all good starting places. So congratulations, you did your first exercise of just making a determination of what's the best place to start. And so that was really, as I said, it's just to try and be deliberate about our choices and to think about where do we start, because as you can see, where did JDEX go? There's a lot of code in this application. There's a lot of libraries, there's a lot of different functions. And so once you find when we start actually reverse engineering, there's only a few things we're actually looking at in code to make this determination. And so, yeah, being deliberate really helps you become a more efficient reverse engineer too. Now moving on to exercise number 2, where we get to reverse it. Oh, I even had slide. Yeah, so I said, here are the API calls, and these are the things. So in exercise 2, we're going to actually reverse engineer some stuff and get into the really fun stuff. So for exercise 2 here, we're going to continue where we left off with exercise 1, but now actually reverse it. So the goal of this exercise is to reverse engineer our first Android application, specifically DEX code, rather than the native. Okay, hold on. I was seeing something in chat from some of my moderators. Just give me a second right here. Just the moderators are a little overwhelmed, so we're adding people. Yeah, so yeah, y'all don't be crappy. I mean, we're all be kind to each other, say nice things. We really don't have tolerance for this. So just give me a second so that thankfully someone else volunteered to help moderate so we can make sure that this is staying positive and supportive and, effective for everyone involved. Okay, cool. Cool. So now thank you to Niru, who has graciously agreed to help out. So now currently we have Brandon, Alec, and Niru helping out. Sweet. So now back to the fun stuff versus, the frustrating people not being nice stuff. Exercise, reversing. So we're going to use this exercise to try to get more comfortable using JDEX and figure out how do we reverse engineer an Android application, determine whether or not it's malware. And so this is an actual application our team had to review to determine whether or not it's premium SMS fraud. So we just want to remind you, like, even if it's hard, take pride in yourself. It's supposed to be hard. You're learning something new. It's likely not going to come easy if you've never done this before, but it's real. It's not some fake application. So some starting points for you to get started. We're using JDEX-GUI as our decompiler, and remember to keep in mind the 3 things we need to identify in the app to determine whether or not it's doing premium SMS fraud. 1, you need to figure out if it's sending a text message. 2, you need to figure out who it's sending a text message to. And so to determine that, the thing you can look at is that send text message API. Which argument is the number it's sending the text message to, and where does that value come from? Next, is it mom or is it a short code? And then lastly, what is that flow to get to the sending text message call? Does it look like the user would be consenting to sending a premium text message, or does it not look like a user is consenting? So those are your goals. This is some of the information we identified in exercise number 1. And now let's get to reversing. Did I have any other info to share? I don't think so. Cool. So ask questions in the chat. I'm probably going to give you about 5 minutes or so, just because it's weird since I can't. Usually in a workshop, I'd be walking around helping y'all. You'd be helping each other. We'd all be asking questions together. But with me just sitting here lonely at my desk, I don't really have a great way to support you rather than just starting to share the answers. So I would love to be sitting at your desk next to you, walking you through this, but alas, we can also look at the positive that we're able to do this all together from all around the world. So start reversing. Start finding each of those pieces required. I mean, clearly this app is doing premium SMS fraud, because I wouldn't have said it as an exercise otherwise. That would be not so cool of me to do. So work to answer and find each of those 3 pieces that's required. This is a very strange situation for me to just sort of be sitting here, but I feel like this will be much more dynamic if y'all even have a few minutes to try and look through and work through it on your own. Oh, there was the question, can you rename variables in JDEX? Let me remember, because I don't. No, you cannot rename variables in JDEX, which is one of the reasons why, if you are probably doing this on a day-to-day basis, it's probably not the tool you would be using. You'd probably have your employer, or if it's your business purchasing more, if it does, I forgot, have the ability to sort of do find callers or cross-references. So if you click on the function name, make sure the function name is highlighted, right click, you can go to find usage. I chose a really horrible one as an example. I'll explain why when we get into reverse engineering this, so let me choose a different one. So login by post, find usage, and then so you can see the two places, or you can find the one place where this is called, and then you can double click and go to there. So you can find cross references as you're doing this. Whoever is asking when there's breaks, it's DVR. You can pause and take a break whenever you want. And remember, so what your goal is once you find where the send text messages calls are, since we already gave that away, you want to figure out what number is it sending those text messages to. And that can be found by looking at documentation and understanding arguments and then tracking back those values. The other thing you want to determine is how does it get to that call of sending a text message? Is it a flow of the user saying, hey, I took this picture and I want to send it to my mom? Or is it something less or a little more sinister, such that it's just happening secretly and then sending a premium SMS message without user interaction? Okay. Well, I mean, I think it's actually, plus might be that we can all keep moving together since there aren't really lots of questions coming in through the chat. I'm going to keep talking through now how to reverse engineer this and have the or how to solve this. Please, 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 if you really want to work through this sincerely, pause it and try to give it a shot yourself. And even pause one part and then do the next, because I think learning hands-on is a really great way to learn it, and then you've already gone through the whole process yourself. But so if it's me and we went through, and I start by going to navigation, text search, just to see, can I already go ahead and find the API call of sending a text message? And in this case, as we saw in exercise 1, we did. So if I go there, oh, I had to hit OK. Oops. And we have in this same method, that's where the only two calls to send text message are. So I have done this quite a few different times. So I know that the first argument to send text message is the number they are sending that text message to. And then the third argument is going to be the body of that message. And then the others are some things you can read. In our case, they don't matter as much for making these determinations. So now we know that we are sending a text message, and we want to figure out of two other questions. Who is this, or what is this mobile number that we're sending the text message to? And second, how does this flow get called? So are we doing this through a, as I said before, the user's driving the whole thing, or not so much? So first, let's start with who are they sending the text message to? So we see that the number we're sending the text message to is passed to send message as the first argument. So our next step is to then see where's send message called. So if I highlight the name of the method, right click, I can do find usage. and we see that there is 3 different places that this is called. All of these are kind of interesting. So if you haven't done a lot with Android, a lot of the Android, most functions, not all because a user could obviously name them, but if you see a lowercase on as the start of a method name, then that's often a sort of built-in life cycle type of method that happens automatically. So on create, for example, happens the first time this activity, com.cp.camera.loading, is created. So it's automatically run as a part of that activity's life cycle. So if we went to Google and search for on request permissions result, we would find out that that is a automatic callback whenever the function request permissions is called. Let's see if I have enough to show you that through a Google search. So I see on request permissions result, so I Google it because I'm like, what's that? I've never seen it before. And so the first thing that comes up is an Android developer documentation. The one that came up is deprecated, so we could always go to the most recent version, but it gives us enough information right here to say, let's see, let's make this bigger. It tells us on request permissions result is a callback from request permissions. So in this case, we can't do cross references to determine the find usage to determine where how on permission is called, but let's go to this. What we could search instead is for request permissions. Oops. So if we go back to navigation, text search, so we would look lowercase request permission. I'm going to say it's case sensitive. And so we see a couple different places where request permissions is called, actually quite a few. So the first thing I would suggest is Android support are largely and usually library functions. So if you have instead options that are in the same package, in this case com.cp.camera, as the code you are already looking in, I suggest that as a starting point. While a developer and some malicious developers do try to use similar or the same naming scheme for their own custom code, it's oftentimes not. And because the on request permissions call was in some com.cp.camera.loading, it's much more likely that the call to request permissions is also in this class. And so we see it in 3 different places: on create, get phone number, get device ID. When we expand this, we can actually see, which permissions are they requesting in each cases. And so we see that of the 3 calls to request permissions, we see send SMS, read phone state, read phone state. Read phone state permission is something that allows them to access stuff like what is your SIM number, what is your SIM ID, your carrier, your phone number, and stuff like that. The fact that one of them is offering or requesting the send SMS permission, and we're looking at send SMS stuff, that's usually just a great first place to start because it's probably more tightly bound to what we're looking for. So this is where they're requesting the permission, but I want to take us back to the on request permissions result. Because if we take a look at this, what we see this is doing is 1, here's the request code, here's the permissions they were requesting, here's the grant results. And so if request does not equal 1, meaning the request for the send SMS permission or whichever permission was denied, they're going to make a little dialog box that says, please allow access. Otherwise, as soon as that permission is granted, they're automatically going to call send message with the argument this service. Remember when we looked at send message, the very first argument to it was the mobile number we're being sent to. And so when we now want to know two different things. First, we need to figure out what this .service is, because that's the mobile phone number we're sending to. Second, this is highly suspicious. The reason being is because they are immediately sending a text message as soon as the permission is granted. Granting the permission that an app can send an SMS message does not grant the app the permission to send a premium SMS message without knowledge or consent. And even if you just think about it as a user, when you grant something a send SMS permission, don't you usually expect there to be a follow-up dialogue of you actually sending a text message, not just saying the app can send a text message? So that is why this is suspicious and sort of raises red flags for me as a malware analyst that I want to keep looking into it. So on request permission result, immediately called send message. That was how we got here because we started in send message. And now what we also want to check is this .service. What is this value? So what we can do, if I click on service, sorry, this is all going to be running a little slower just so I can keep the live stream up and healthy. Come on. Usually there's find usage on variables too. I don't know why it's not giving it to me. Okay. So since it's not giving me, for some reason, the opportunity to right-click and find usage, the other options, if this wasn't all in the same class and you scrolled up and down, is you could say text search. We could do service in case you're not positive it's all in the same class. And then I often put the equal sign because that's where you can then find where it's being assigned to the value, which is what we are interested in, not just the where they're using it. So this told us the same thing, that they're setting this .service in this class's onCreate. And as I said, onCreate is the method that is called immediately whenever the activity is created. So what we see is there's two places here in onCreate where they're setting service. One is down here and one is up here. So let's reverse this function because onCreate has now come up a few different times for us. It also came up when we were looking to see who was calling request permissions, because remember we were interested in request permissions because on request permissions result, call send message. So this is where, as a reverse engineer, you're just trying to keep it straight in your head and trying to remember the different things that call each other. While this might sound natural and quick to me for how I'm doing it, remember I've also been reverse engineering every day for like the last 8 years. But when I started, I largely commented every single line I was reversing to keep straight what it was doing, and I often drew flow graphs or diagrams on pieces of paper saying, okay, send message calls send text message API, on request permission result, and a couple other things. What is it? On create also call send message. On request permission result is a callback whenever permissions request. So you can draw those diagrams to help you keep all these things straight and move through it at your pace, at whatever allows you to start to understand how. And the more you do it, the quicker it gets, and you can start to keep those different relationships straight in your mind. So going back here, our goal still right now is determining what is this .service set to, because that is the number we're sending the test message to. So if we start just looking at this function, it's called onCreate, which, as I said, built-in function whenever an activity is created. They're just setting the, as it says, context view, sort of UI, so we're not super interested in that. what we're interested in is anything tied to this.service. So even if we looked straight here, we see that object.getStringService, we're reading the value from JSON. And so now we're interested, where is this JSON object coming from? Because that's not super common if you're, say, sending it to mom or dad, you would check, your contacts or have the user enter a phone number if you're trying to send a text message that way. And so if we go into where this JSON object is coming from, we find that it is the result of a function called to login by post. That's pretty interesting. So let's see what login by post does. We can also check that it's taking one argument, and this argument, the developer's named operator. And this raises the red flags even more because the one argument they're passing to login by post is whatever the SIM operator is for the current device. Sorry, I'm just scanning to see if anything needs my attention on the chat. So the one argument we're passing to login by post, which is returning the JSON object that we're using to get the number we're sending the text SMS message to, is SIM operator. So the way, as I said before, premium SMS works is that each premium number has to be registered with a single phone carrier or mobile carrier. So I'm going to use for a second US-based carriers because that's where I'm live. So let's say that I use AT&T as the person who I get mobile service from. And a malware developer or anyone registered their premium SMS number though with T-Mobile. They can't have me send a text message to the T-Mobile registered premium number and get paid. They have to have me text a number which they registered with AT&T. So that's why I'm very interested that they are sending the SIM operator, because that's one of the cases where malware cares very specifically about which SIM or mobile carrier a phone is using. So let's use login by post. If we right click on it, we can go to declaration and see the function. So remember, this is the SIM operator code that identifies whether I'm Orange, T-Mobile, what all this, Vodafone, all the different carriers, AT&T. And let's see what we're doing. So we're getting the release version of Android that the device is running on. If you did not know this off the top of your head, you could Google this string and it would tell you it's a built-in property value. You are also getting the model for the phone. We're getting the device's phone number and the device ID. And then we're creating an HTTP request. So we have this very sketchy looking URL. Remember, we can't just use sketchy as a determination of whether or not something's malware. The reason why this is sketchy is that it's using an IP address first off, rather than a resolved domain name. And then as a part of the URL parameters, they're sending our argument, which is the SIM operator. So to their remote server, one of the parameters they're sending is the SIM operator code. And they're doing a post here. And then to that URL connection, they are, what are we doing? So we're creating an input stream. Where's buffer? We are reading from that input stream and then writing nothing. So are we using a phone number anywhere? Okay, so they're not actually using those even though they grabbed them. So what's happening here is we're just creating a URL connection with the parameter of our SIM operator code to this remote server. We're reading it into buffer. We're writing our buffer to a byte array output stream, which is just another type, and then we're creating a string of that. And that is what we're returning from login by post. And login by post was, remember, used up here, and that string that is returned from login by post is turned into a JSON object, and then we are getting the value from that's in service, and that's who we're sending the text message to. So in this case, as a malware analyst, I am now confident enough that this is doing, well, okay. I'm pretty confident that this is doing premium SMS fraud because they are getting a number back from a server that is the only argument they send to the server to make that determination is your SIM operating code. This is where reverse engineering becomes part art and part science, is that using solely static analysis, no, I do not know exactly what that value is, but the more you do this, you begin to understand the risks for your context versus the art. And I personally would be pretty comfortable that this is likely doing sending to a premium SMS code based on those signals. Let's say this was a very high profile app. There would be high risk associated with getting it wrong. If I flagged this incorrectly, then I might check and see if there is any sort of dynamic signals of what code is getting back or things like that and do more digging. But let's say I'm confident now that this is sending the text message to a premium SMS number. So we've now solved 2 out of our 3 different issues. We've done 1, it is sending a text message. 2, we're pretty sure it's sending a text message to a premium SMS number based on the fact that they got it from a remote looking server, only using the SIM operating code. So that doesn't look like there was much user interaction in deciding what number to send the text message to. And lastly, we need to decide if the user is driving this based on disclosure and consent, or whether or not they are sending it. Oh, YouTube's alerting me again. I hope the stream's healthy, but YouTube's saying it's not, but my encoder is. The last thing, sorry. Oh, this sure is live, huh? We need to determine how all of this code is triggered and whether there was a disclosure popped up to the user telling them, hey, we're going to send a premium SMS message. It's going to cost this much. Are you cool with it? Or is this happening automatically without the user knowing it's happening? So if we begin tracking back again, so we're at our send message method, because this is the one that actually sends the text message in one of these 2 places. It's either going to do it right here, dividing up the message because the content was too large, or it's just going to send it as a one-shot. And then we are going to see, okay, who calls this? And we did this before and we found there were a couple of different places. Let's just start with on request permissions result because that was the first place. That's the path we've done before and I don't want to confuse you. And so we saw that as long as the send SMS permission was granted, they would immediately send it. So that means that while I don't like this, that means that the only places that would be okay for them to disclose and get consent from the user would have to be prior to the request of the permission. And the request of the permission happens to thankfully be in the same class, but we found it earlier by doing find usage, is they're requesting the permission send to SMS up here in on create. On create was also the other places we saw where they were calling send message directly. So where did it go? Request permission is right here, and then or they have send message here and here. So if we look at this if clause, in both if and else, if they would end up calling send message. Just in this case, it would go through the jump of requesting the send SMS permission first. So let's start by just looking at this block of code to see if this shows us enough and how we end up here. So if we look at this else, we find that within onCreate, we're doing find view by ID, which is an r.id button.send SMS, and then we are doing set on click listener. And we're actually making these in the function onClick. OnClick is another one of those lifestyle functions. As you can imagine, it is what is automatically called whenever the object in question, in this case the thing named r.id.button_send SEN SMS, is clicked. All of this can be very confusing. If you have never built an Android app before, my suggestion to you, if this is something, this RE is something you're very interested in, is build your first Android app. And my reasoning is it is much easier to reverse engineer something when you can put yourself in the mindset of how someone would build it, because that's what you're looking for, is patterns. And so totally cool for this workshop if you don't know what these things are, but you will get much more exposure if you even go through that first intro to building an Android app that is on the Android developers website. It doesn't have to be fancy, but it will show you things like views and creating buttons and how all these pieces tie together. So yeah, back to the point. So we know that as soon as whatever this button is clicked, we're sending a message, because it's either through request permissions or directly we're calling send message. So we want to figure out what's on this screen, what's happening on, is there a disclosure? So this can be where things get a little more complicated in reversing based on how the user has built the app, because it looks very different to a developer when you are using the way you build it, with different XML files versus how it ends up in a compiled application. So I'm not always sure when I start getting into the UI stuff, but one, if you have the app on a device, one thing you can do is run it. You might get charged money, but that's one thing to figure out what's happening in the UI. But another, my starting point is usually to just look for that value. So I'm going to look for button_send SMS. And we see in a couple different places. What we're actually looking for right now is this one, because it's telling us that we're going to set text. And we want to know what is the text that's being set on this button. And so we're going to look for this dot button. And this dot button, okay, it's the text that's coming back from the server. That's also not super common or super, whatchamacallit. That doesn't make us very, you can't see me, I'm talking with my hands trying to look for the world. Doesn't make us very confident what's going on. I did remember last time I found this, there was a way to determine it exactly. Oh, so we're also looking for this text view, because this is going to be the message, since we're also within the same UI of we are setting the text. And so this text is also coming from the server. So in this case, if I had never looked at apps that are similar to this, I would try to find examples of messages and responses coming back from the server. What you would actually find if you are able to get this from the server is that the text that is shown is start application, and then the text on the button says let's enter the application. And if that happens and you click the button to say enter the application, then they immediately begin sending the premium SMS messages, thus stealing your money and things like that. And so congratulations. You have now become an Android app reverse engineer and reverse engineered your first app, confirming that this piece of malware is doing premium SMS fraud, and so you're protecting users by flagging it as such. So one thing about this, is that one, this is actually a part of a malware family, an early variant called the Bread SMS family. So Alec, who is one of our moderators here in the chat, has actually done quite a bit of conference talks about the Bread SMS family, and so this is one of their early variants of it. If you do one of the later native reversing applications, that is one of their later variants of how then they try to regress to hide their behavior by moving it into native code. And so, yeah, this is a lot of common signatures of the Bread SMS family, calling it Thai camera. They largely targeted Thailand mobile carriers through their premium SMS fraud. And once you start to do different things like this, you'll pick up signatures of like how they tend to do similar types of post requests with similar values coming back, similar, spelling mistakes that happen quite a bit, which then that's where that art piece of reverse engineering comes in, with your confidence level of how deeply you need to dig. But yay, we reversed something. I'm so proud of you, and I'm glad to have you join our group. I'm not going to save that. So I'm going to give you all a minute if you want to post any other questions in here before we move on to the next thing we're going to do. Oh, what about boot service send message status? Okay. I forgot. Let me reopen. I'm so sorry. It's also very weird now, y'all not being able to see my face or all my hand talking. Don't worry, I'm still doing it. Can I explain more about native code and how malicious activities hide there? So that is what would be the second half of this workshop if you're interested. So it is exercises 5 through 8, I think, or 5 through 7 in the workshop of, as an Android developer, you can include compiled C or C++ code within your application rather than Java. And just it's largely considered a higher skill set needed to reverse engineer and understand compiled native code rather than Java or Kotlin, just because it can't be so easily decompiled too close to source. So some malware developers assume that, okay, because it requires sort of a different skill set, a higher skill set to reverse engineer, they think they can hide the behavior by moving it into native code. You can't really hide it. I mean, your code is still doing it. It's just different in that respect. So that's why some malware authors do that. What other questions? Yeah, sometimes APIs change between Android releases. That's how you add extra features or add new security controls. And that's why you might see applications checking what API level they are running on, because then they would use different API calls based on that. And so the question I was giving is boot service send message status. Let's take a look. CP camera, boot service. I can't sing, but I like to sing. Give it a minute. Okay. What was the function? Send message status. Okay. So in send message status, what we are seeing, this.phone, get phone number, and then they're sending SMS post back phone, and they're sending the same post, but this time without the SIM number. Instead, they are using the phone number. So let's see where this is called. I jumped the gun way too quickly to close JDEX. Is it possible to somehow debug this send message dynamically, like from an Android simulator? I would suggest, usually a lot of malware will check that you're not running in a simulator or emulator. They will at least check for that you are running on a real device, just because that's one of the easiest ways for them to try not to get caught at mass scale. And I don't know that you'd necessarily, I mean, yeah, you can probably, and you could hook it with FreeDit. It depends on what you're trying to determine when you say debug this, send message dynamically. If you're looking for the values, sure, we're just not covering dynamic analysis in this. There are resources out there that are great. Okay, why? Oh, it's still running. So I will keep looking at questions. Is there a good resource for finding the APIs that are protected by each permission? I've played around with a few academic. I mean, just the docs, I think there might be better ones. Feel free, some people might have looked at it to do that at scale, but I'm usually just reverse engineering. So like if we look at send text message, so send text messages with an SMS manager. Are there Android dev tools that are not resource hogs? Probably not, it's Java, but I mean, I think resource hog is different for everyone's different computer. But yeah, Java tools tend to be pretty in-depth, and especially analysis tools like Ghidra, JDEX, or any other reverse engineering tool, because they're trying to process, index, and everything, all your different, all the different files that are included. So it's just a very intensive operation that we're asking these tools to do. So I shared all the tools I knew of. So send text message. Where is it? Usually it tells you that these are, it's somewhere they tell you that this is protected by the send SMS permission. Oh, here, well, it says it send text message without persisting. It tells us it's required there. Where was it on send text message? Oh, here it is. So this is usually what I use for the person who is asking about turning permissions. I think actually in the actual Android source tree, you know, these are all, it's actually annotated there. So that might be better if you're trying to do this at scale. That would probably be a better resource than just trying to look at the docs. But if you're just trying to find if something's protected, then the docs it is. Okay, hopefully JDEX is up. My computer's fan is now no longer running super high, so I think that means we might be good to go. I keep accidentally going to full screen on this Mac. Okay. Oh, goodness. It is not close. So let's do this instead. Oh, I can see it right here. So send message status, when I highlighted it, is all here, and it's in on receive. So on receive is used in those things that I told you are like a receiver, that they can register they're looking to listen to something, and that whenever they get that signal, they will then automatically begin executing. So within the class of boot service, it's declaring its own internal receiver. So it's saying class my receiver extends broadcast receiver, which is the big Android thing. And so in this case, this receiver is registered to receive the sent huge SMS action. And so the next thing we would look to see when it does this is who is sending this action. But quickly, if we want to see, so get result code, which I believe is what they're sending along with the huge action, they have this case switch that they send message status. So the thing why send message status is not especially interesting for our determination of whether or not it's SMS fraud is that this does not trigger any sending of the text messages and it's not getting any of the values that we need. If you are doing a deeper dive investigation into this family, then this is something you would probably write up about how it's still interacting with its command and control receiver of sending different statuses back. So it's passing in a number 2453, each of those meaning something different based on get result code, and it's passing that to the receiver for this phone number. Often they're doing something like this to try and track how many text message is this single phone number, because they want to know and expect how much money they should be getting paid, or is this not working? Am I likely being detected? Should I stop performing this action? Things like that. So hopefully that answers that question. If a malware is written in Kotlin, do I get Java as output in JADEX? Yes. Kotlin also, quote unquote, compiles down to Dalvik bytecode. So when you then run that in the decompiler, you get decompiled Java back out. Yeah, so those were the two questions. Cool. So now I'm actually closing this and we are going to move on to exercise 3. Okay. Okay. So we're taking off our malware analyst hats, and this time we get to put on our hats as bug hunters. And so now we're going to change it and use these reverse engineering skills to look for a vulnerability in an Android app. Along with this, I hope you become more comfortable and learn more about the different components within an Android app, because it's not like a straight up binary or executable where it just has a single control flow. You know, it's an application, and the different components within those within that application has different relationships, and you know, especially between intents and the different components. And we just want to reverse some more because it's so fun. Oh, do you write Android apps full time? Nope. I've only written test applications when I was trying to figure out how a malware author might try to do something, or writing a POC to try and trigger a vulnerability. I did write it though to try and learn how Android apps work. So I did, when I was first getting started, when I joined the Android team and didn't know a single thing, I wrote a lot of different examples of the foundational tutorials to try and learn more about the pieces of an app. So here's our exercise context. The application name of the sample is fodaprovider.apk. So FODA stands for Firmware Over the Air Update. So OTAs, FOTAs are whenever your phone tells you we need to do an update. Almost always nowadays, you are not plugged into a USB to update it. You are often doing it over either mobile data or Wi-Fi. Actually, that's not fair, and that was showing my bias of geolocations. In the US and Western Europe, you are largely doing it over the air. Outside those locations, it is still very normal to download it via the USB too. So we're going to look at this application. It is a real, or it was, thankfully no longer is, a real over-the-air provider, and we need to do a security audit on it because it is pre-installed and it's obviously very privileged if it's able to update, you know, all the software that is running on your device. And so specifically, because it would be very broad for me to tell you, look for a vulnerability. For this pre-installed application in particular, you are concerned that there may be a vulnerability that allows it to run arbitrary commands. And so that is what you're looking for. That is the context. You are, you know, on the front lines trying to make sure you've audited this for security issues, security vulnerabilities before it goes out to thousands and thousands of users pre-installed on their device such that they can't remove it. Starting points. Suggested, I mean, you can obviously choose whatever you want. 'Cause I'm not, you know, the police, Android reverse engineering police telling you what to do. So what are entry points to the application? If you are concerned that someone else could cause this application to run arbitrary commands, then how could they get those commands to this privileged application? What types of entry points would allow it to accept arbitrary commands? Also, what are API calls that allow execution of commands? What does that mean? So those are my starting points to you, suggested starting points. So if we look at that, entry points to the application. Remember, what about app components that are exported? Because an exported application means that anything else on the device could interact with it. And, oh, I didn't mean to show this slide yet. Pretend you didn't see it, do it your own, reverse. And then we can come back to this in a minute or two. I wanted you to look up the API commands on your own. Oops. Okay, so get started. This, as I said, you can open this up, and I'll go ahead and open it up too, since it might take a few minutes for me. I'm showing you again. Don't look, don't look. So we're gonna start up JDEX GUI again. This time we're using photoprovider.apk. Oops, that was not on the screen that's being streamed. But photoprovider.apk. Oh, just in case, so you can still see it there. So, and again, a reminder of app entry points. Think about how could something else external to this application send commands, and also what are API calls that within Android would allow the execution of commands. Again, feel free to pause this because I don't really know what to do besides start talking through some things since, yeah, like I can't really reach out through the computer screen and help each and every one of y'all. So some of the common, the common API calls for, that's not what I wanted to do. The common API calls that can execute commands within Java code, some of the common ones are runtime.exec or process builder, so you can look those up in Android documentations. And so, and when I ask you about entry points, so let's start there together. Let's open up the Android manifest because that's a great starting point when you're not sure what else. So some of the first things we see here is that, yes, This one does have an application subclass, so that's good to keep in mind. One thing that also stands out is this is running as a shared user ID of Android.uid system. So within Android, at least for the so within Android, each application runs within its own sandbox. And so that is one of the critical aspects of the Android security model, is that each application is within its own sandbox, and they're sandboxed from each other. However, there are cases where apps may need to run within the same process, and thus they can do that by declaring Android shared user ID within the manifest of their app, within the manifest of their application. And so the way that this works is that, let's say application A declares that it is Android shared user ID, new fun shared user ID. And then Android B also declares that it's using shared user ID, fun, whatever it is I said. I should have remembered. Now, if they're both signed with the same certificate, meaning that they're signed with the same developer's private key, then that means that the operating system is going to put them within the same process, within the same sandbox, and they are now a subset. Not a subset, a superset, literally the opposite of what I said. So it is a superset of all of their code, permissions, etc., and it looks to the operating system like it's one giant application running all of these things. There are also a few couple special user IDs for the operating system, because as you can imagine, there are some apps built in the operating system that need to run within the same process as others. And so one of those user IDs is Android UID system. It is the most privileged user ID other than root. So it has almost every permission available in the operating system, because remember when I said when apps are running within a same shared user ID, it's the superset of their permissions. So A can declare send SMS and B can declare read SMS, and now that process has both send and read SMS. So this raises our red flags immediately, because we now know this app is running as a very privileged user. Not everyone can declare this. Your random app you download from the Play Store or a website can't just say, hey, I'm system and be super privileged. It has to be signed with the same private key as the operating system image. So that's to say, if the manufacturer has signed this application with their private key, and thus it's the same key as the whole operating system was signed with, what we call the platform key, then that's the only time they can say, hey, I'm running super privileged, I'm system. So in this case, you can find the cert by going to meta-inf. Then we see the cert. Not that one. Oops. There's something here where I can actually show it to you. Oh, APK signature will not just show you the binary, but will show it to you pretty. So sorry, this is small. I don't know why it's not using the same font size as elsewhere. But what we can see here is while these fields, the subject, the string ones, can always be spoofed, you could go then on a device where you found this app and double check they match the actual fingerprints of the key. But this one is correct. I verified it. So this is MediaTek sign this operation, or sign this application. So on their devices that they had signed with the same key as this application was signed with, this app can get the system user ID, the very privileged. So this just makes us that much more interested and concerned and really want to vet that there are no arbitrary command execution vulnerabilities, because if a command is executed within this app, it is executed within a very privileged context with basically every permission. So that's part number one. If you're interested more in things about pre-installed apps and the Android UID system, last year at Black Hat, I did a whole talk about vetting, reversing understanding pre-installed applications and the special things about them, including examples about shared user ID. So feel free to go, that video is up and you can take a look at that there. So we still know, how can an app go ahead and send arbitrary commands to this? What are entry points that something could, a server, something can say, hey, you, photoprovider.apk, run all these commands for me in this super privileged context you're running in. So let's go ahead and take a look. As we said, there was an application subclass. There's service. There's actually a couple different services, but this is where it's important to remember those exported components part. So, like I said, by default, all components are not exported unless they say Android exported equals true, except if they declare intent filters. So this service, com.appsphoto.syshopper.sys service, although it doesn't say Android exported equals true, because they have declared this intent filter, Android intent action appsphoto sys service, suddenly any other application on the device can interact with this service. When I say interact with this service, what I mean is that it can start the service, it can bind to the service, it can stop the service, etc. And when you're sending an intent, you can also add extras, like strings, numbers, options, stuff like that. So when we start looking at the code, that's something to keep in mind, that if this service named sysservice is constantly looking and able to be interacted with via intents from other components on the device, then we want to see if it's what it does with that information. This service, on the other hand, task service, cannot be interacted with from other applications on the device, except for others that are running a shared user ID system, because it does not say exported equals true, and it does not have any intent filters here, and thus only other code that is running within this process, within this sandbox, can interact with task service. This one's interesting. We have a receiver here called write command receiver. And again, it doesn't say exported equals true or exported equals false or have a permission tied to it. So one thing you could do, let's say all of these are exported, but you only want one thing to be able to talk to it. You could put here permission equals and a custom permission, and that would mean that, okay, yes, this is exported, but only other applications with this specific permission are allowed to interact with this. So this does not have that there, and thus it means anyone can interact with it. So that's the same for this receiver. This one too. And yeah, so we have two things that stand out personally to me. Also, folder service, download service. Could I get it to download something I'm interested in? However, that one's not exported, so never mind, I take it all back. And here's all the permissions it uses. So if we're using the new skills we learned from exercise 1 of making deliberate decisions about where we start our reverse engineering, to me the first two places I want to start are write command receiver or sys service. Write command receiver because it is exported, unprotected, and it has a super interesting name tied to what I'm looking for, and sys service because it is a service that is also exported and anyone can interact with it. So I want to make sure I understand what it's doing since this application is so privileged. So let's open those two up. We're going to do sys service and write command receiver. It might take a minute, so let me look at the chat to see what we've got going on here. Does Android have mechanisms to allow an application to specify what other applications can send messages to? Oh, okay. Apparently I already answered that. Can I use bind service to execute arbitrary commands? It depends. As we will see, bind service depends what their binder interface interacts with. Okay. So, talking to yourself for a long time sure takes a lot of energy. Okay. So here we have write command receiver. I'm going to close because I made the font so big. That's why this top line looks so funny on mine. And then I also wanted service. Okay. So let's start with write command receiver. Remember, it's a broadcast receiver, so the way it works is it has to declare what it's listening to register to receive, which it did in the manifest. And so on receive is called whenever it receives that message. All this green stuff is where JADEX failed to decompile, so it's showing us the Smalley code. So that's what's going on there. And yeah, so that's where, it looks sort of if R0 equals 0, we're going to close, so that's what's happening. The one, if you don't like seeing that, help out the JADEX team, and since it's open source, and help fix some of these things, or, that's sort of why there's some more expensive decompilers too. So on receive, as I said, this is the thing that happens whenever the other, anything else on the device sends, where did write command receiver go? If anyone else sends either of an intent with either of these two actions, because right here, that's where the receiver has registered to those actions, then it's going to call on receive within this automatically. So we're setting the variable A to our context of the application. The context of the application is sort of like the world it's living in. You can look up more about that. Here, we're finding out which action the intent had. So if it's write command receiver, we perform this, and if it's opera receiver, we do this. So we had seen here that we were registered for those two actions, write command receiver and opera receiver. So this is where the code is determining which one triggered it to start running. So if we get write command receiver, then we're creating a new file with, this is where the intent was set with a string extra. So whoever sent this intent, it could be any untrusted app or component on the device, said, hey, I'm going to set this extra value. Package file name equals my custom file name, whatever it is. So we're going to create a file with that file name. Then we're going to acquire a wake clock. You can look it up by looking at the APIs. Basically, that means keep the phone alive, don't go to sleep. And then we are going to install package. If you look it up, it's perform the OTA with whatever that file is. Yeah, so not good, not secure, but that's actually not what we're looking for in the context. So we're going to keep going. I will come back to this in a second. So if we look at the other one, opera receiver, then we are getting a string extra command, which is very interesting because, again, the get string extra is what whoever decided to send this intent to the receiver is set whatever the string is. And so this is where the decompiler didn't work out quite right, so I would open up Smalley if I couldn't guess what this means, but basically here they are printing this out and the decompiler just sort of failed there. And so string extra, they're then splitting it based on spaces between each of them and then passing it to A. In Android apps, you will often find lots of apps whose all their class names, their method names, and things like that are all lowercase or single lowercase letters. That is one of the most common obfuscation methods. It's known as ProGuard. It is not a signal that it's malware. It is not a signal that it's anything malicious. It is just one of the most common obfuscators used to hide intellectual property and make it a little hard to reverse engineer. If it's been a while since you've done any Java, remember that Java allows for overloading of names. So for example, here we have two methods named A, and that's allowed because one takes a string and the other takes a string array, and thus their method signatures are different. So just keep that in mind. JDEX has what they call deobfuscate functionality, where if you turn it on, it gives each of these custom names. To me, I like that less, so that's why I leave it as the names. But this becomes very difficult if you are using a tool that it does not allow you to rename variables and functions. But yeah, just to give you all that heads up. So the same thing here. So we want to go to this function A that we're passing these strings into. Come on, highlight the function. Why won't it let me go to the declaration? Okay, we're going to just scroll up, or we can click here on the left for A, the function, versus this is a variable and this is a method. Also, yes, I know Java uses methods and C++ uses functions, but yeah, like terminology, and y'all know what I mean. So here's our function A. It's really not all that pretty because, as I said, JDEX kind of barfed on itself, so we're seeing Smalley instead. But remember, this is the string array of the commands that were passed in, and here's our function. So we're setting a register to -1, a register to 0. We have an empty string here, and then we have process builder. So we're calling the constructor for process builder. Or no, we're just creating the object. And here on line 39, r3.init, r8, we are calling the constructor with our string array. So I had told you process builder was one of the APIs that allow execution of commands. So let's look more into that, since we are now calling a constructor with our rather, you'll see the Android ones. Since we're now calling the constructor for process builder with these arguments that were received from whoever decided to trigger this receiver. So how does process builder work? So constructors. Process builder constructs a process builder with specific operating system and arguments. So let's go to that. That's not, oh, that's not helpful. Basically what this does is it builds in a new process where it's saying those are going to be the arguments to it. There's a better definition somewhere. Oh yeah, well, okay. So R3 is our process builder. Init means call the constructor with R8. And then we call R3.start, which when you look at start in process builder, it will begin executing the commands we passed in. Starts a new process using the attributes of this process builder. So we could give it additional commands with command, but since we already gave it to them in the constructor, we are now executing whatever those commands we received via the intent directly in this process, which is very privileged in running as system. So that's really not good, and we have confirmed there is an arbitrary command execution vulnerability within this, and it is extremely serious because we are running at systems. So they don't need to worry about any permissions. They largely can do anything they want. The way that another app could do this and trigger this is they would construct a new intent, which you can look up, and then they would just do set extra options command is the name of the option they need to use, and then they set whatever values they want. And it's actually that simple. So if you had a device that had this version of the app on it, you could even do it via ADB to test super simply and show that you have this POC that allows you to run these commands. And so obviously this app has a lot of concerns within it. You know, I also showed just by passing in a file name, you can have it update to whatever firmware image you want using that install package request, because that's not just installing an APK, that's installing a new firmware image, you know, through updates. So, okay, I don't have it here, but I do have it listed in the workshop. This app is called ADAPS OTA, and they are where Black Hat talks in, let's see what year that was, about all the different issues within this, because I gave y'all one example of it. But as we saw, there were a lot of different security issues, so I think it is a good place to start if you're trying to understand what some security issues could look like within pre-installed applications. So yes, under solution for exercise 3 here on the workshop, I have links to the Black Hat talks about this application, as well as, remember, for all these exercises, I have solution videos if you want to go through at a later date. So the Black Hat talk was from 2017 called All Your SMS and Contacts Belong to ADAPS and Others, because not only the 2 security issues we found, there was also some spyware going on too. So there's both slides and videos from those Black Hat talks. And congratulations, you found a vulnerability in an Android app, and I am oh so proud of you. But I will now take a second to try and catch up if there's any questions. I see our moderators have been doing an awesome job. But let's see if there's anything else that I should answer for everyone. Just to clarify, because this application was running as system UID, yes, you could, an untrusted app could end up being able to install any application on the device, because this ADAPS OTA has all of the permissions basically by being able to run a system UID, and thus if an untrusted app sent it the command to say, hey, install this app for me, it would do it. They could, yeah, they can run basically anything. Yeah, if you get errors, you can definitely try decompiling with another tool. I'm just not, because we're using JDEX in this workshop. Yeah, so using the fact that this accepts any commands and run it, you can, like, the world is your oyster. You can think of so many different ways that you could, commands that you could run of interest. You really can just do whatever you would like. What else? So for example, going to Reddit in the browser and it automatically opening the app, would this likely be an, yep, and oh, you already got there. If an app is using a native library, do you also RA the lib binaries and search for vulns? Absolutely, it's code that's running in the application, and thus you would want to look there for vulnerabilities, and there it becomes more, it comes a little more similar to how you would look in, say, like Linux or other binaries, and more memory corruption types of things too. But what's kind of interesting, well, no, I'm getting ahead of myself. Like, I think anything running of the Java native interface is super interesting, because then you have access to Java and the Android APIs as well as all the native code. But yeah, that's part 2. Okay, cool. Well, I hope y'all are enjoying this thus far. We've made it through 3 exercises. Are there any other questions about that exercise? This moves much faster when you know we aren't interacting with each other in a room going through everything. A bit unrelated, but how is the content in the GitHub repo licensed? My intention is that people can use this. Please give credit back to me because I put a lot of heart and soul and time into creating this workshop, but my intention of making it public was that I hope people use it to go teach each other because I can't be everywhere to help teach. And especially when we consider how do we make our industry and our community more diverse and equitable, especially if we consider so much of Android reverse engineering. I mean, let me back up because I think I was going to not say it the way I intended. Our industry, our community, especially here, affects so many different people. As I've said before, we have a lot of responsibility to protect over 2 billion Android users and ensure they have safe, secure access to internet and thus information. And so yet our industry looks pretty similar across the board. And I know I'm not the best teacher for some communities because, for example, I'm a white woman learning in the US, native English speaker. So if you bring it back to your communities and want to teach, that would just make me so happy. And hopefully by providing this info out there, it lowers the burden to go and teach and get more people involved and, you know, more voices to help create safe, secure, mobile stuff. So yeah, that's my answer to the GitHub repo license. I probably need to look into it more, but I'm not super smart about that stuff. Not super smart. I'm not super educated yet about all of that. What's the most stressful part of my day job? I'm now a Project Zero security researcher, so my day job's a little bit more different. Thankfully, I don't think it's too stressful because it's research on Android. It was worrying about not catching malware or things soon enough and that people could be harmed if I didn't work fast enough. So always keep in mind of people who are doing all the content reviews across all the different platforms, malware analysis, is they feel a lot of pressure, and that's usually why they're in these roles, is because they care a lot about helping people, and when they miss something, they're probably beating themselves up way more than other people. If an app with low permissions were to send arbitrary intents based off untrusted input, would it be a security concern, or is it? It's not just sending it. It's, as you say in the second part of your question, Jack, that it's up to the handlers that they should only accept trust input they trust, and sanitize and things like that. Cool. So exercise number 4. So our goal here is Binder is a really integral part of Android. It is the IPC mechanism, and it's how IPC being interprocess communication, and thus it's also different than if you've been reversing or looking at other platforms. So I wanted to do an example of finding a vulnerability within an application when it's using Binder. So in this case, you might have seen that I've done talks and research on a specific vulnerability in the binder itself, but in this case, we're going to look more for a vulnerability in how an application uses Binder, not, Binder itself. And so here's our application context. Again, we have a pre-installed app, this one called hunsystemservice.apk. And because the goal is to teach you reverse engineering skills, not just how to do different contexts, we're going to keep the context the same. You're again looking for something that is, whether or not there's a vulnerability within this application that allows it to accept and execute arbitrary commands from something else. You know, again, a big concern. And my reason for keeping it the same is that I showed you one example already of what it might look like when an application is accepting arbitrary commands and executing them, but it can look a couple different ways. So we want to look at another example. So for you to keep the creativity flowing of the different things you may look for versus just one option. So again, we know the same starting points. What are the entry points to the application? What are API calls that can execute commands? And the other information I need to give you is a little about Binder, because you can probably guess that since I'm facing it, the issue will be within Binder. So one, Binder, as I said, is an Android inter-process communication mechanism, and it allows for remote method invocation of functions. So basically what that means, if those sound like a lot of big words, is that Binder can say, hey, I'm a server and I have declared and implemented these different functions. I'm now allowing you as a remote client to execute or invoke these functions. They are still run and executed within the server's, process or context, not within the client who is saying, hey, invoke this. So for an Android app developer to use Binder, they have to define a Binder interface using Android interface definition language. And so this is what it's basically saying is, hey, here's this interface and these are the functions that I'm making available to clients from my server. Does that sort of make sense? I know for me, it took a whole lot to get this in my head of what this really meant. And one thing I did was try writing Android apps that invoked Binder, because that helped me understand. And then I reversed them, because one of the things about Binder is that the Android app compiler or build process kind of changes what you write as a developer into how it looks to the application. And so I wrote something and then I'd build the app and then I'd open it in my decompiler to really understand those relationships. It's similar to if you want to get started in binary reverse engineering, some of the first things I say is start writing C programs and then putting them in your disassembler and working through them so you can understand how code you write as a developer shows up in the tools when you're trying to reverse engineering it. So first things first, if you are trying to find the AIDL that the developer wrote for their binary interface, you can look for classes that extend the I interface class. And almost all the, okay, that's good. So we're gonna open up this application. Again, we're using Hun System Service. Let me see in chat. Do I set a target, like X number of bugs to be found in X time frame? I personally don't, because the bugs have to exist to find them of a specific thing, but you could also, maybe Natalie has anything to add if she does it in that. I don't think so though. Yes, you can use this workshop to teach others. Please just give me credit. Yes, both exercise 3 and exercises 4 were quote unquote legitimate apps. They were not written specifically as malware. Yeah, okay. So now let's close photoprovider.apk and open up Hun System Service. Ooh, where'd it go? Please pause as I find it. Do y'all have Hun System Service in your VMs? Okay, so since y'all have Hun System Service, go ahead and open it up and you can start working through this while I figure out why I don't have it here in my samples directory. Yes, I'm aware I have the wrong APK open. I had photo provider. I was going to open Hun System Service, but because I'm not running in the VM, I thought I'd copied all the samples to my local machine, but I guess I didn't copy that one. So just get started on the exercise. Feel free to send questions in the chat while I get this open. So it's your time, since me jumping into a solution right automatically off the bat wouldn't be that helpful anyways. Yes, an alternate link for the VM was put on Twitter. Just look for Android app RE. But if you're having trouble still downloading from Google Drive, then the things that usually work if you're getting the quota message is logging into your Google account first, or whatchamacallit, changing browsers, or Jan is hosting it for us so kindly on his server. Whoops. Yes, so this exercise is just in V2 VM. Oh yeah, thank you, Mr. Compton, for jumping in and answering that. So remember, your goal is, we've talked about a lot of different techniques of how you can find starting points. So don't just forget all the ones we've used earlier. One, strings can be interesting, looking for API calls, entry points, different things like that. And trying to put together the whole control flow of how something remote or external to this application, whether it's a separate HTTP via IP or something like that, or another untrusted app on the device, whatever it may be, trying to figure out how something like that might communicate with this app and if it can send arbitrary commands to be executed. Cool, unknown. I did say this part of the training would be all Java, so sorry if it's boring, you can leave. But I think other people find it interesting, so maybe not. Or maybe leave it for them so they can learn. Will you guys be available even after session for doubt clarification? I'm not a guy, no, but those who follow me know. I mean, you can always contact me on Twitter. I gotta be honest, please look through other resources like the published videos and the text within the GitHub first, because it can get exhausting when I work to put information out there and then people don't check that first, and I get lots and lots of Twitter messages when it's already out there. So please check that first. Please contact. If I have the capacity, I do try to respond. But please also be understanding if, especially in these times when we're all sort of in this crazy world pandemic world, and you know, our own capacities, resiliency can be low at different point, our reserves. Sometimes I won't get to it, but I do intend well. But when you post it publicly, hopefully other people can chime in too. Oops. Okay. I think I have downloaded the APK. How's it going for y'all? How's the reversing? Is it making sense? This is a hard one, so I'd usually like give people over an hour as we talk through it before just jumping into a solution. Okay. Let's try this again. Here we go. Hun System Services. So again, we can do a couple different things. We can start, if we wanted to, by doing string searches with command. We could start by opening up the manifest to see if anything stands out as interesting. We could start by looking for API calls. I'm going to let this continue trying to compile, so I'm going to just start with Android manifest. And we actually have a small manifest here. Let me have a sip of coffee. So first step, thing that stands out, Android shared user ID equals system. So again, we are operating in a very privileged context within an app. So if whatever this app runs, or if it accepts any arbitrary commands, they will basically be able to do anything. So first up, or not first up, I already told you all that. So shared user system ID. Anything else interesting? There's our package name, build. It doesn't ask for a lot of permissions, and that might seem counterintuitive because again, this is a pre-installed application. And so one of the reasons why it doesn't really ask for any interesting permissions is because it's running as that shared user ID system, it doesn't have to. Other things that are running as shared user ID system already have, and thus it is able to do this. And so it can do anything, not just these, so don't let that trick you into it. Oops, let me close this so I don't keep getting distracted. Okay. And so now we see there's barely any code in here. You know, we have our application, which it is not declaring an application subclass. It's just saying this is an application because there is no class name here. And then we have one service and we have one receiver. So really not much going on. So the service is named System Operation Service, and ding, 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 exported equals true. So we will be interested in looking into System Operation Service because anything can interact with it, as we've said before. And then we have one receiver, which is called Device Owner Receiver. Remember when I mentioned that an application can protect even when it's exported who can interact with it? That's what this looks like here. So in this receiver, they said Android permission equals Android permission but bind device admin. And so in that case, this means that not every untrusted application can interact with it. It's really only the applications or components on the device who also have the bind device admin privilege. So that's how you can protect and lock things down, even if you need it to export it to some other components on the device. So System Operation Service is what I'm most interested in. If I needed other ideas and nothing stood out here within the manifest, another thing I could do, if I'm specifically looking for execution of commands, I would try some of the different, oh, we're not quite ready for string searches. Again, when I turned down the memory, I changed it from JADEX allowed to use 4 gigs of memory down to only 1. So it's a little slow on me. We're just going to cancel that for now. So let's go up here to COM. What is it? Honeywell, Tools, Hun System Service, and then System Operation Service. Ram, and how many exercises are we going to do today? I've done until 4, and I would like to know whether 5+ will be covered today. That's, as I said in the tweet, 5+ is native code, and today we're only covering the Java reverse engineering. Depending on how we feel after we get through this, there is one other, or exercise 8, I believe, or maybe it's 7. One of the exercises later on is deobfuscation of Java, and looking at that, we may or may not look at that one after this based on how long this takes, how we're feeling. So yeah, I do try to provide all this information in all the Twitter threads, so in the future, yeah, go ahead and check those. So System Operation Service. Again, this was exported without protection of a permission, and thus anything we do can, or anything else on the device can interact with it. So this service, as seen by the scroll bar on the right hand side, is very large. The reason why they have so few components is because they basically put everything in here. So the one thing that stood out to me is, when I was looking at this, is it has a on bind function. So when I see a service is exported in a manifest, one of the first things I do is look to see whether or what's in its on bind function, because every service will have one. It just depends whether or not they will return something. So I think it's all the way at the bottom is where they put it in this app. So in this case, if a service is not declaring or using a binder interface, then this will say return 0. In this case, they're returning in binder, which I believe if we hover, it will tell us. Oh, it won't, not hovering. Oh, come on, little computer, you can do it. So it will show us that this binder object is iSystemOperation.stub. And so this binder operation, when it's returned in onBind, that is us saying, hey, I am this server in this server relationship. Here's an object that you can use to become my client and interact with me and invoke some of my functions so you know what is being made available to you. So we want to see and learn more about this binder object. So we see it is of the type iSystemOperation.stub. And yeah, so if these different strings start to catch your eye, yeah, they're interesting. So let's now go to it. Let me in. Y'all, if we don't get to the deobfuscation part today, it will be because it's in part 2. It's just I needed to constrain this time-wise, so it's in my head. It was partly for exercises here at the start, and then because that's the halfway point. So usually I would do the other deobfuscation exercise after we do native code. So it just depends. It will be done. They're already listed in the GitHub workshop. It's just based on timing for today and whether or not I would have enough time to really talk through it. I at first thought there was no way we would have time, but now it turns out talking to yourself goes a lot faster. Okay, so this is where binders can get very confusing in the sense that they look like they're using, when you look at the code in a decompilation, you're going to see a lot of the internals that make it work. And we don't need all of that to reverse engineer at the sort of logical level of interacting with a binder interface. If you're looking for vulnerabilities within that binder, then sure, you're interested in that. But remember how I say that the developer defines their binder interface through an AIDL. And so one of the ways you can find this AIDL is by if a class is extending II interface. And so we are here. And so these are this is the function list of everything that this binder interface in our service system, sysoper service, I think it was, wherever we started. What was it? System operation service. These are all of the methods that remote client can evoke. And so there are a lot of kind of sketchy, kind of scary things, going on. But that's where remembering your goal of research helps you keep things in mind. And so when you're just scrolling through this list, there might be a few key ones that make you interested for our context of trying to find, does it execute arbitrary commands? Get URI from file name might be one of them. And where did it go? Exe command might really stand out as something you want to take a look at. To be honest, when I was first reverse engineering this app while I was still on the Android security team, because it popped up in our queue, the string, I did a search for just the string command, and this popped up, and obviously it was worth another look to keep going at. So I didn't do a string search in this case just because I am running on limited memory. But yeah. So yeah, there's a couple of different things that have commands in it. Let's start with exe command. So here we just have the declaration. How do we see the code? So a couple different ways. Let's see. It's being weird on me. You can't highlight find usage or go to declaration because this is the declaration. But what you can do is just search for it. But what we're going to find is it is actually, I believe it's down here in this same file. So you can also just do Control F or Command F within, oh, y'all are all in Linux. Oh yeah, there's also like, yeah, exe command. And so here we see sort of the binder interface of it where it's having to use all the binder internals, but what we want is, okay, it's not in this function, it is in another. We're looking for the server-side implementation of it. So we're going to close that. In this case, I'm just going to do a text search. Once you know the name of the function or the method, you know it has to be somewhere. And here it's actually in system operation service. Is it? Oh no, it's right. I don't remember. We're going on a ride together. So, real life, y'all. So yeah, so here it is actually defined in system operation service. If we were to scroll up, I believe this is in a class name that tells us it is inheriting the other, so that's how you know it is tied. The binder interface. So I think it's like system oper service 3 or something like that. Do, 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 do. All the sketchy functions. Come on, we're almost there. Yes. Here it is. So, oh, I could have just come here. So each decompiler kind of shares it differently. So in, I believe it's Jeb, they actually treat this as its own different file as a class rather than putting it in line here. So here, it could have been much more straightforward. So we're seeing mbinder is set to this stub, and here's the implementation details for this stub. And we saw that it brings us to exe command, and it shows us how exe command is implemented here on this server side. And that's, remember, the mbinder object is what's returned to the client or whatever untrusted app or any component that says, hey, system operation service, I want to bind to you. So they would call bind service. So now we want to see what does it do? Because the way that the binder interface would work with this remote invocation is that they don't have to do the extras like you did for Intense. They could just literally remotely invoke this based on the binder objects that's returned. So they would say exe command and then give whatever string it takes as the argument. So we want to find out what is it doing with this argument and what is it actually doing in the code. So again, for some reason, JDEX couldn't deal with decompiling it and reverted to Smalley. So we're saying RA equals this, R3 equals 0. Then we're creating a runtime object in R5. This is an Android API or even Java API, so you can look it up to find out. Then we're doing runtime, get runtime.exec, and we are immediately passing in our argument that is passed to exe command, that string, into exec, and then it is run in what's similar to, like, you can think of it as a Linux command line shell. And so that is happening in our super privileged process system that's running as system UID. And if this is, again, something of interest, you can go back and look at the pre-installed Black Hat talk I did, or pre-installed the apps Black Hat talk I did last year, because I do talk through this example there too and talk a little bit more about Binder. But again, let's say I am an app you downloaded from some random website. You didn't even go through, any sort of store. You found an APK and installed it. If I'm a malware developer and I'm confident that you're running on a device that has this Hun system service pre-installed because I know I'm interested in these Honeywell devices, then what I can do is I can say, hey, start system operations service, and then bind to system operations service. And using that information coming back, I can then go ahead and call exe command with my super mean, I'm going to but I'm going to run my devices, or all my commands that are going to do bad things on your device in a privileged process that basically has full reign to do whatever it likes. And so obviously, again, a big concern. And so you have found another vulnerability. Background on this one, so we reported this to Honeywell, and then they also contacted the United States' Industrial Control System, CERT, and they issued an advisory because this was used on tablets that are used in industrial control systems. So Android has a lot of different uses and impacts outside of just your mobile phone device. So if you as an Android developer and you're just seeing an APK, it's important to think about all the different places these may be used. Yeah, so I'll give y'all a minute for the stream to catch up with me to see if y'all have any other questions. Again, a huge thank you to our moderators who are doing such a great job of answering a lot of y'all's questions. Huge thank you to them. I'll leave this up, but what else? And here's the succinct way in word form of what I just said of the solution of how something could use this. One of the ways, one of the best ways to secure this app would have been to, if you expect other commands need to be run, hard code those commands that you're okay with. Have a whitelist of commands that can be run rather than accept any sort of arbitrary ones. And another way to protect it is through permissions. If, say, it is truly 100% necessary, you're locking down that permission such that only apps with the same cert or something can do this, and maybe not run as the privileged system user ID process. Instead, declare each permission you're going to need. Can we have a short wrap up on interface, iBinder, AIDL, IPC? Whew, it is hard to shortly wrap up all of that stuff. So let's put it in terms of app. App stuff. So Binder where's that slide? Let's put that up. IPC, interprocess communication, allowing different processes to talk to each other. And in this case, Binder allows it in the sense of creating a client-server model. So this app acts as a server saying, hey, other apps on the device, I make available this functionality. You can connect to me and invoke it if you know how to use it. And so I suggest for anyone interested in looking to go further with this is read through all the developer documentation on Android of how to write and develop an application to use Binder, and then do some samples yourself, because I think that's how I learned it best. But in terms of AIDL is then where the developers declare on the server side, hey, this is the functionality I'm going to make available. Native stuff, obfuscation. So at least we can start talking about some of this and we'll see how far we get. How about that? Obfuscation. So there's a lot of different ways. Like if we just talk about, if you just go through everything we do today, it all feels pretty obvious, right? You just read Java and then you can find all the different things that an app is doing and determine does it have vulnerabilities or malware. But there's a lot of different ways that developers can try and hide that. So for example, like the big category is often obfuscation. You might use packers, you might use some encryption. Malware authors definitely do it to make it raise the bar of the investment required to understand what their app is doing, but so do developers who are developing legit, benign, non-malicious apps, because they've put a lot of resources into developing the functionality and they want to protect it and make it harder for people to and they might have wanted to protect. They don't want people to easily be able to find all their secrets in terms of the things that set them apart, that is the features, how they make money. But when we're thinking about obfuscation and all the different things that might make it hard to determine what an app is doing, there's a couple different types, and this is not, it doesn't include every single option, but it includes most of the big categories. So first, you can have malware authors may do something as multi-stage, and meaning that you have a first stage that looks pretty benign, and only if it meets a couple sets of things do they download second, third, fourth, fifth, sixth stages, where the really sketchy code does. Some developers do this. It's still a little sketch if legit developers do multi-stage, just because then they could literally be downloading anything, and they also leave themselves more open for, like, if they don't code it exactly right, man-in-the-middle attacks. So it's also called dynamic code loading. Sometimes app developers do it if they're trying to hot patch, meaning they change behavior based on some things. But yeah, I mean it more in the malware developer stage, and that's where I see it most often, especially for where Android malware is currently. Almost all of it is multi-stage as of now, just because the bar has been raised. If you're using dynamic analysis or large automated pipelines to analyze apps, then that's where you might see delayed execution of. Malware developers can pretty safely assume that the large-scale automated pipelines aren't going to be able to run apps for super long periods of time, because they have to churn through thousands and thousands of apps, and thus malware developers may delay the execution of their bad behavior, for days, hours, etc., knowing that if you're doing lots of apps, you often can't leave an app running on a phone for that long. Something we haven't gotten to yet that is a feature of Java is that you're able to invoke methods via what's called reflection. And so you may find that malware developers choose to use reflection rather than a direct call to the API. The thing about reflection, though, is it still will ultimately require a plain text, human-readable string of the method name and class passed to the reflection APIs, or you will see the reflection APIs, aka like invoke. And so while those strings can be obfuscated off the bat, at some point, the Java virtual machine has to have that plain text string, which means you can get to the plain text string too to find that it's invoking those APIs. So anytime you see something jumbled or not human readable passed to invoke, you can follow and decrypt or deobfuscate it yourself. Targeting can make things harder to detect, especially if you're relying on dynamic analysis. Because especially in terms of something like premium SMS fraud, they're only going to register with certain carriers. So they're not going to run and send text messages if you're on a carrier they haven't registered with or outside the geolocations they're expecting. And so while this, developers can do this too, they might change their behavior based on if you're in the US or Europe or South America or Africa or Asia, it's also something that malware authors do. So let's say I had that Thai camera app. Bread SMS almost never registers and does premium SMS fraud for any users that are on US mobile carriers, just Southeast Asia predominantly. And thus, if I run it on my phone, it usually looks like a totally benign camera app. So that's where the static analysis really helps us, because they still have to have that code within the app, even if dynamically they don't run it. Cloaking. So malware authors, really especially for Android, try to hide their behavior from Google. So it's pretty funny that while Google headquarters is in Mountain View, some of them just assume that if they try to do stuff for their apps like on US holidays, that means, or at nighttime in California, that means no one will ever see it. But we'll see things like that. There's a lot of malware that will refuse to run on Pixel devices because they think that will make it more likely to be caught. Just interesting things like that you see that sometimes you're like, oh, that's an interesting choice. But yeah. The last one is collusion. So apps working together to hide their maliciousness. So this is where, like shared user ID especially can come into place. And we did see it also with the Bread SMS. So go back to Alex's call or Alex's talk that I mentioned about that SMS family, is that as it evolved, it decided to begin, it would only do the malware when 2 different apps were installed on the device. Both of those apps being signed with the same certificate and thus declaring the same shared user ID. And so one of those apps would request the send SMS permission, but it would not have the send text message API ever called within the app. The other application would not request the send SMS permission, but would have the send text message API. And so if you look at that second one alone, it looks like, sure, it tries to do send text message, but it doesn't request the permission, and thus it won't be able to. Whereas the other one, you're like, okay, it requests the permission, but it never actually calls the API. It's only when both of those applications are on the same device that then, it is running within the same process into the operating system. It looks like it's just a superset of permissions and code that then it's able to do its bad behavior. So, and one thing I always try to remind people is if you want to be able to deobfuscate it, you can. The main decision you need to make is whether or not it's worth the time, the resources versus the expected output to go ahead and deobfuscate the whole thing. Because the application at some point ultimately has to be completely deobfuscated for it to be able to run. Like, it can't run in its obfuscated form. It has to be unpacked, decrypted, something. So if you are trying to and willing to put in all the time, you will be able to get to the end of the tunnel and find the plain unobfuscated version of it. So yeah, don't get discouraged. It might take too much time, but it is still possible. So some common aspects of Java, of obfuscating the Java code, not getting into the native code, is obfuscated strings. Whereas if you see obfuscated strings, it's a good thing to look at whatever method those strings are being passed to as arguments, because that's usually going to be the code that deobfuscates them, since at some point they have to be deobfuscated. Scrambled class names, which one thing is I just don't rely on class names much. I usually completely rename everything anyways, but that's one way they'll try to obfuscate it. And then lastly, obfuscated code. So if they're actually trying to obfuscate the Dalvik executable, it's often in those cases either downloaded from a remote source, through an HTTP GET or something like that, or it's an obfuscated file within the assets directory of the APK. And so the best way to usually find is to deobfuscate it is to, one, either run it and get it from memory, or look for any calls to dex class loader. Because once it's deobfuscated, that's the API call they use to load any new Dalvik bytecode into the application's process, and thus then you can usually follow back the path to figure out what is the deobfuscation algorithm in order to get the plain text. Because dex class loader is going to require the deobfuscated version of the dex. They can't just accept the obfuscated version. We're not going to cover that. Yeah. So, okay, we can quickly talk about exercise 7. I'm not going to go through all of it because I'm not going to, I don't have the final solution here, but we'll talk through how to do it in the last couple of minutes. So exercise 7 is you have an APK and the goal is to deobfuscate strings using static reversing techniques. So here are my suggested starting points to you, is that you find the string that you need to deobfuscate. There's one specific one in this function. It is a piece of malware. And you're going to identify the routine that deobfuscates it. So that's what I want you to do first. Did I not put what the name of this one is? Okay. It is something that has Clash in the title. I don't remember it. So we're going to do File, Open. It's clashoflights.apk. Since JADEX doesn't have a great interface for just being able to scroll through all of the strings, which most tools do make available, I'm going to go ahead and tell you that it's in the com.supercell package. So look through some of these functions. I suggest especially using your manifest as entry points because that's the code that's going to be, executed. And in there you will find a clearly obfuscated string that you need to know the value of. So I'll give you a minute and then I'll give you another pointer in case you haven't found the string yet. Y'all, as I've said a few times before, this is usually a two full day workshop. So today is just part 1, which is just the Java code, because native code reversing has a lot of new information that would cover that is completely different, but you have to understand the Java stuff first. So it sounds like there is interest, so I will schedule the part 2 for some other time. But yes, and all the information is already out in the workshop. But yeah, it was in the Twitter threads about this. I'm sorry if you're disappointed. So if we take a look at, where do I want you to take a look at? So our launcher activity is com.supercell.clashofclans game app. So I think that's as good a starting point as any. When I was doing malware analysis for this app, I was able to just see a listing of all the strings in the application using a different tool. So the obfuscated strings stood out much more obviously. But now I'm trying to figure out a different way for us to get there, especially since we're getting short on time. That was not the function I thought it was, or the class I thought it was. Where is it? That's where we are. Okay. Oh, yeah. I'm at com.supercell.game app. Oh, did I open the wrong one? Ah. Oh, no. There's 2. Okay. So in com.supercell.titan instead of Clash of Clans game app, we see, I think this is where our clearly obfuscated string is. Yeah, so we see this crazy string, and so you can imagine that if you are just looking at an output of strings like Jeb provides, then this whole big thing stands out quite a bit. And when you come to click on it, come to see it, it starts to get interesting because now you see it's within a web view. And so that becomes interesting, and it's loading data. So if you do webview.loadData and look up that API call, then what it's saying is this is usually like the URL or whatever you should load within the WebView data. So this is extremely interesting. And because this is obviously not clear, but we see it's being passed to 2 functions prior to load data, which would expect plain text getting to it. So that's where we can come and look at these, because we would assume one or both of these 2 functions are the deobfuscation mechanisms. Okay, I need to go to the Z1 class. So apparently if you click on A, it's just taking us back to this A function. So let's come to the Z1 class and open that up. And so when we look at com.supercell.titan.gameApp, it passes to A first, and then the whatever's returned from method A is cast to a string and then passed to B. So those 2 combined together seem to be our deobfuscation. And so through this, you could just copy and paste this into a new Java class if you wanted. I often use Python just because I'm super quick, but this decompilation is pretty good, so you could probably just copy and name it Java and run it over the string, just like pass it in to that to see it deobfuscated. And because what it's doing here is we see that it is taking each of our ASCII digits is 1/2 or 1 nibble of a byte. So it's instead saying, okay, these two characters 77, let's cast that to the hex byte 77, because we're creating a new byte array with its length cut in half, you know, because instead of 1 byte per each character, it's now 2 characters equal 1 byte. And so that's what A is returning. We're doing each of those, and now we have a byte array of the values in our string. And then we pass that new byte array to B as a string. And so we have our key here, KCQR19TZ, and for each byte in what was our obfuscated string, we are going to XOR it with our key, which is a pretty common, super simple obfuscation mechanism. And then once it's XORed, that's all of those bytes is what we return. And that is then what's loaded in the data web view. I know this is super fast, it's just we're running out of time. I do talk through this in the solution video that is on there. So if we go back to Android, maddystone.github, you will see the deobfuscated string. It's basically trying to contact CoinHive, which for a long time, I don't know if it's still up, does Bitcoin mining. And so the deobfuscated string is this: script source. Let me make this bigger since. Script source from coinhive.com. And then we're going to do var miner equals new CoinHive. That's their key for CoinHive, the number of threads, and then they're going to start the miner. So in this case, it would be malware because it is trying to do CoinHive mining without the user's consent. And the background, or not malware, but the Google Play Protect potentially harmful application because they banned, you know, the coin mining, at least when I was on it. I mean, things might have changed. But so yeah, that was the obfuscated string. They were trying to hide from any quick, you know, automated analysis that is looking for CoinHive or something like that within an application. So you can also see here, this is how I say transliterated those two functions or those two methods in that Java class that we're doing the deobfuscation. When I am trying to write a quick Python script to deobfuscate something, it's often, in this case it was easier to see, but you don't always have to understand a deobfuscation mechanism to say it's this type of algorithm in order to be able to deobfuscate it. I mean, the goal is to deobfuscate it, not to explain they're using so-and-so algorithm and this encryption or whatever. So that's why I use the term transliterating. If you're interested in more information about common obfuscation techniques, at Recon last year, I did a quick 30-minute talk with 60 slides through a series of obfuscation techniques solely in Java, not even getting into native code that an Android botnet was using to hide its behavior. And to me, it was some pretty advanced things I'd never seen before. So that was at least topical as of summer of last year. And with that, thank you. I mean, I'm honored that so many of y'all were willing to spend so many hours of your day to join us on this, and I think it's pretty cool. Thank you for being kind to each other and supportive, and I hope this has piqued your interest in Android App RE, because I think it can be super fun and super interesting, and it has a big impact. I mean, you're really helping people whenever you help secure Android applications. So I'll give y'all a couple more minutes to send any questions in. But please, if you haven't already, if you have the means, please consider donating to the San Francisco Marin Food Bank or your local food bank. Because as I said at the end, a lot of people are really, really hurting now. And I assume some of our friends who are in this live stream are some of them. And if we can help feed people, at least the San Francisco Marin Food Bank does a lot with any donations. They're able to provide 2 meals for just a single dollar. So it has a lot of great impact. Yeah, so it would mean a lot to me if even just $1 you continue to donate. Yeah, so I'll wait to see if any few questions come in. Yeah, so it sounds like there's interest for the native part. I'll look on getting another time scheduled to go through there. I think we'd probably only need, we wouldn't quite need 4 hours to go through it. But yeah, so I'll do that. Please be patient. You know, pandemic times are hard, but I will look to get it scheduled, and I'll use the Android app RE Live Again hashtag on Twitter to let you know. Thank y'all. Yes, and a huge thank you to our moderators. No fuzzing video. I don't really do fuzzing. I'm sure there are other people out there, but yeah, it's not me. Cool. Well, with that, I guess you'll have a wonderful rest of your day, and I hope you have a delightful weekend. Okay. Bye.